Good morning, everyone. My name is Ayrton Coles, and on behalf of our Tennessee Transportation Assistance Program, in collaboration with the City of Sevierville and McCain Swarco, we would like to welcome you to our ATC cabinet training. So we'll have a morning session here from 8:30 until 12 Eastern Time. I'll let Eric introduce himself whenever he starts sharing his screen. I would like to say thank you for Joseph Dodgen from City of Sevierville, Frank Rogers also, and we also have here in the room, many of you may know, Don Maas, all right, from Swarco. So all the expertise you may need in one webinar here. So thank you for all for allowing us to come in here and share and stream this presentation. For those of you online, please put your name on the chat box. Maybe add your agency as well, where you're coming from. Keep your camera off during the presentation. If you need to ask questions, just put it on the chat box and address that to everyone. I will be sending your certificates, but give us about a week or so I can go through the Zoom analytics and get all that information. For workshop materials, I will be sending an email out with the presentation that Eric shared with me. All right, so this is going to be after the class. It's probably going to be this afternoon or tomorrow. And we don't have a TATE exam for this class, so don't worry about that.
Oh, there's not going to be a test? Come on.
No test. So this is going to be an easy one. All right, so thank you, everyone. Let me just switch my camera here to.
Don't share yet. Is this mic hot? My laptop.
It should be, yeah.
My laptop literally just crashed. So I'm going to introduce myself as my laptop is giving me the little blue smiley face.
All right, maybe what
frowny face.
I'm seeing your names coming in, so I guess my mic is working. So can anybody give me a okay for Eric's? Can you hear Eric Itzo here?
Hi guys, can you hear me? I have the little green light on.
Yeah,
okay,
we're good.
All right. Well, I'm gonna jam for about 3 minutes about myself and where we are here in Sevierville, Tennessee. For those of you who haven't visited the city of Sevierville, Tennessee, this is a lovely little city in East Tennessee. It's a premier tourism destination. Great Smoky Mountains National Park, Dollywood, all the things. They see about 18 million tourists a year, or at least that's how many they were seeing when I lived here. I lived here from 1992 to 2021. This week is actually my 4-year anniversary of leaving Tennessee. I moved back home to Maine. I like the colder weather. So I spent 20 years in IT before joining intelligent transportation. I feel like I'm not even talking to you guys. Talking to the audience here. And I spent 11 years here at the city of Sevierville in information technology, water and sewer communication, intelligent transportation, and also running the IT group for the entire city. I met Don Maas in November of 2011 at the intersection of the northernmost intersection in Sevierville, and we hit it off. And then 8 years later, I joined Swarco McCain. So I'm an ITS engineer, which means my job is integration. My job is training. My job is figuring out stuff and figuring out how to make things work. A lot like Don Maas, except I'm not an electrical engineer. All right, laptop's coming back up. But for those of you who know me, I travel not as much as Don, but I travel about 26 weeks out of the year, performing these trainings. But I'm also moving forward into the working smarter realm of, hey, let's use the internet for these kind of trainings. I would love to have everybody who's on the Zoom call be here in Sevierville with us right now, sharing coffee and donuts. But as it stands, you guys are doing this from the comfort of your desk, almost back up. So I guess I'm going to need a new laptop. This thing's embarrassed me enough. Crying out loud. Launch the meeting. I'm going to make sure I exit Teams as well because nobody wants to see my Teams banter. Apologies, everybody, for the brief technical delay. Stand by. All the things that open when you open your laptop. Oh, good. All right. Yes.
So while you're getting that ready, Eric, I can go through the chat box. So we have Tennessee DOT, Virginia DOT, City of Kingston. Let's see, who else? Stantec, Nashville,
Perfect.
City of Lebanon, Gresham Smith, Acon, City of Goodlettsville, of course, here from Sevierville, Chattanooga, Mount Juliet, Connecticut DOT. Let's see who else here. Howard Stein, Hudson from Boston, Knoxville, town of Farragut, and I may be missing some folks here. City of Bridgeport, Connecticut.
Oh, hey, Bridgeport. What's up, Mike Powell?
So City of Charleston, New York, also ITS, City of Atlanta, Virginia DOT again. So just let me know when you're ready, Eric.
I'm
just killing time here.
I'm ready for you to thank you. I'm ready for you
Oh, yeah.
To let me share.
right.
Also, I want to remind everyone that this is a recorded session, and I'm reminding you jokers here in front of me right now, if you guys want to have any fun with me, this is a recorded session. So watch the F-bombs. No, just kidding. Okay. Well, that's what I look like. Okay. I'm going to share because I don't want to look at myself. All right. Screen 2. Share. Okie dokie. Ayrton, you can see that?
Yeah.
Oh.
There we go.
There we go. I'm screen sharing. Oh, that's annoying. Your laptop. Okay, testing, sound off. Anybody can hear me? We good? All right. So you missed that part where I probably knocked into the cabinet. Okay, so this presentation, well, the session this morning is actually a compilation of 4 different presentations. When Ayrton and I worked this out, when we came up with this idea for this particular training in Sevierville this week, I wanted to cover a review of everything that we're doing in 2025 in ATC cabinets. I wanted to talk about cabinet troubleshooting. I actually wrote a presentation for the city of Philadelphia last year that went in depth of how to actually troubleshoot and dismantle and repair ATC cabinets and how to do it safely. So you know what you can take out of that cabinet, even if you have to get the tools out, and then how to run the intersection while you're performing the repairs. We have a local contractor here, Progression Electric, based in Knoxville. They're on the front line here. They are the ones that have to go out and fix this equipment on a sunny day like today, or on a rainy, sleety, nasty day like what you guys had last week. Regardless, you have to go out there and work on it. So you have to know how to take these cabinets apart. You have to know how to safely take these cabinets apart. So I'm going to review ATC cabinet troubleshooting and repair. We're going to take a break after that because as far as recorded session, we only have about 3 hours now that we've gotten through all of our technical difficulties. So we're going to take a quick 15-minute break and pause for question and answer from everybody on the internet, all the Zoomers. Then we're going to talk about cybersecurity. This is something, of course, I go back to my IT roots and talk about the networking, the protocols, and how to keep the bad people out. But now I am also starting to focus on the cabinet security itself. More and more agencies are adopting smart locks, smart access control technologies, and I'm gonna take it on to discuss why we care about that and why we need to actually do that. And I'm glad VDOT's on the call because I know you guys invest heavily in smart locks and secure access to your cabinets. And then at the very end, I'm going to talk about the McCain Omni EX intersection control software, what's new and what is down to the installation method and new features and how we're actually using the application to make the intersection safer. So I even have some use cases there. I put that at the very end because I want to be fair to everybody in the audience, here and over the internet. If you came here for ATC, that's what we're talking about first, and cybersecurity, and then Omni. If you really want to know how we're pushing the industry as far as innovation and safety, stick around for the Omni portion. Now, before we get started, though, so far this is the 4th time I've done this, and I struggle with this slide. So I want to pay a little bit of tribute to a titan of our industry who passed away at the end of last year. Scott Evans was, I'm not looking at you, Don, I can't look at you right now. Scott was the Chief Technology Officer and Vice President Engineering for Everly Design for 29 years. He's one of the co-parents of the ATC cabinet. Scott Evans had a conversation with Swarco McCain's Vice President Engineering in 2011, and he called him up and said, "Hey, Reza Rizudalab, our VP of Engineering," he says, "Hey, Reza, I got an idea, but I'm going to need your help. I need you to get your boss to fly, you and your boss to fly to my office, and then talk this over with my boss, the president of EDI." That was the genesis point for what we know, what we now call the ATC cabinet. That was they did it. It was their volunteer effort. Lots of people worked hard on this project, but we wouldn't have an ATC cabinet today without Scott. We wouldn't have half of what we have in the industry today. Anything that says EDI is because of Scott. And he also had good taste in cars too. I like his little Porsche. I mean, it's an air-cooled German automobile. I'm more into Irish cars myself, but we had good banter. I loved working with Scott. He was amazing. I worked with him on the tail end of his career with the ATC Cyber Cabinet product, it was a pleasure working with him, and I already miss him, honestly. So we can't. I have to give credit where credit's due there, and I really miss Scott at this point. So, moving on from that, let's talk about ATC cabinets. So this section is high level of ATC cabinets, but I also want to cover what's new. If you've ever attended my previous ATC cabinet classes, I get down into telling you what the input assembly is and the output assembly and the current rating of the switch packs and their capabilities. I'm not going to go into that level of technical review in this particular session because I want to kind of get down to the nitty gritty. I want to tell you what's new and where we're going with this platform. First, I'll kind of give an introduction on the ATC cabinet, how we've progressed over the last 40, 50 years. Starting with the history lesson. Way back in 1976, our first standardized traffic cabinet in North America, NEMA TS1, still a standard and specified by many agencies across the country, across North America. So this cabinet architecture goes back to the 70s. Introduced the concept of ABC connectors. You guys, Progression Electric, you see these all over Tennessee. The ABC connectors are standardized. If we are going to build a NEMA TS1 controller or a NEMA TS1 cabinet, the wiring of those ABC connectors has to be the same, has to match Anyone else's has to use the same connectors, the same specifications, everything. We cannot go proprietary with that. Those ABCs, those ABC harnesses must conform to the standard. They did give us a D connector for manufacturer-specific items. That's why when you look at a McCain controller with various connector boxes, the D connector is a different size than an Econolite controller or a Unix traffic controller and whatnot, or peak traffic controller, or ORCs, excuse me. So that's something manufacturer specific. So when we do controller swaps from one brand of controller to another in a certain brand of cabinet, sometimes you can't plug in the D connector. The controller was the power supply, and there was no SDLC interconnect, meaning that there was no intelligent data exchange between the controller and the devices in the cabinet. So our video detection, our PED detection, our pedestrian controller like the Polera ICCU2 or whatever that's called, so on and so forth. 1978, Caltrans came out with a 170 state specification. Not a standard, it's a spec. Introduced the rack mount, 19-inch rack mount form factor, introduced a kind of the connectorized modular assemblies, so you can actually easily take apart a Caltrans. It's easier to take a Caltrans cabinet apart than it is to take a NEMA cabinet apart. I suppose that's the proper way to say that. And the controller interfaced with the cabinet through this large rectangular C1 connector. So all of the field wire, all of the wiring going from the cabinet assemblies into the controller was this big, fat rectangular connector. Similar to ABC, you had to match that spec. 1992, NEMA updated their standard, introducing TS2 Type 1 and TS2 Type 2. This introduced the concept of SDLC communication, synchronous data link communication. Thanks, Don Moss. As an old IT guy, I always have to say the acronyms, so I don't sound like a complete IT nerd. So introducing SDLC communication allowed for the controller and to communicate with other cabinet devices. This is why in NEMA TS2, all of a sudden we have to make sure that the monitor and the controller are programmed to be in sync, and that the permissive card has to match what's inside the controller, inside the jumper card and the monitor, because the two devices are exchanging data. They're saying, hey, this is how I'm programmed. How are you programmed? Oh, okay, we agree, or we don't agree. Now, the advantage to this is to introduce the concept of field check, where the controller says, okay, I'm turning on these outputs. And then the monitor says, yep, you did. Versus before, the monitor just saw voltage on terminals. It didn't know what the controller was trying to do. Also, the monitor's clock was then set every minute, which is very convenient. How many times has anybody gone to pull a monitor log, and then the monitor log says, yeah, we went in a flash on October 3rd, 1984. And you're like, no, that's not today. But the clock was wrong, and there's no way to easily set the clock, or setting the clock in the monitor is difficult. So it's simple little innovations, but it made everybody's lives easier as far as the technicians. In 2006, we came up with, or the feds got involved and created what's called the ITS version 1 cabinet. This was combining the best of both worlds, of all of the worlds that were available at that time. So Caltrans rack mount, NEMA TS2 SDLC. It was the precursor to the ATC cabinet. So when we introduced the ATC cabinet, what we also did, what Scott did, Reza, is they introduced the concept of modern technology. We don't have to use 70-year-old load switches anymore. We don't have to use pretty much 100-year-old flash transfer relay design. We don't need that anymore. We have, as technology improves, it's supposed to get smaller and more efficient. Except that wasn't the case in the traffic world. In the traffic world, we just rearranged the cabinets, but we used the same old load switches and the same old flash transfer relays until ATC. Then we brought in modern technology. This is an unlock for us. Now we can start doing more things at intersections, and we basically eliminated previous boundaries and barriers, and now we can say, all right, well, what do we need? Do we need more channels? Do we need to monitor flashes? How can we really grow this system to be something compatible with something more like a controls engineering system, like a water plant or a sewer plant, nuclear plant, whatever. So that's where that was the unlock that we needed in the industry, is modern technology and that's what the ATC cabinet's built on. Again, this is the why we care section. I want to focus on one thing real quick, calling out the ATC family of standards, the ATC suite of standards. When we're talking about ATC cabinets, we're talking about the ATC 5301 standard. This is the definition of the cabinet architecture. It's the functional spec of how the cabinet should operate. It defines how the serial bus protocols communicate. So messaging, timing, data payloads, all of the things. All of those definitions are actually inside the spec document. If you ever want to read it, it's riveting, trust me. But it is a baseline operational and functional spec, as our friend Joe Herr would say, of how the cabinet operates. This is all they gave us out of the spec on how to build an ATC cabinet. All along there, guys, is, we could use that to troubleshoot this cabinet next to us. No, this is the functional spec of the cabinet. Now, this is this is what we had to, what the industry has to work with on how to build an ATC cabinet, and this also means that the manufacturers have a little freedom and liberty to build the cabinets differently. So a Swarco McCain cabinet might look different than a Econolite SafeTran cabinet, which might look different than a cubic trafficware cabinet or a Mobotrex cabinet and whatnot. So what I always pause on this slide because I want to emphasize one thing. Our assemblies and what I'm about to talk about with these various assemblies and features, these may not be interchangeable between manufacturers. The cabinet assemblies that are manufactured by the cabinets. Now the pluggables, high density switch pack, monitors, serial interface units. These are all made by EDI. McCain private labels these, they paint them yellow. EDI private labels for the various manufacturers. So you might think that you're holding a McCain switch pack in your hand, but these are all made by Everly Design. I've seen cabinets where we have 3 different labels of switch packs. We have a Econolite SafeTran, an EDI, and a McCain switch pack all next to each other. But really, they're the same thing. I can't stress that enough. What I need to stress. Ayrton, can you move the camera over here, actually, to the cabinet real quick? Oh, geez. Sorry for the extreme close-up, peeps. What I need to stress, though, is that the input assembly, the output assembly, the various assemblies that the cabinet manufacturers themselves make, you can move it back to the screen now, those are manufacturer specific, more than likely. Don't assume that you can go to an Econolite or a Mobotrex cabinet and take a McCain input assembly and stick it in there, and all of the wiring and everything is going to is just going to fall in line, because this is all we had to work with. So it doesn't say what kind of connector or doesn't. There's no thou shalt or thou shalt not build the cabinet this way out of this spec. It's a functional spec. Okay, let's talk about the features and benefits. Why we care about ATC. Why the progression of the concept. In the beginning, a traffic signal cabinet is just nothing but a big metal box that turns lights on and off. All right, so it's show of hands, how many people have ever heard the cabinet just be referred to as a box? Yes, you guys too on the internet. No kidding. Oh, it's the traffic box. It's more than a traffic box. There's a lot going on in there, and at this point, IT is involved. Here we have Cerebral IT representing here as well, and I had to apologize to begin with, because I said, Preston, you're probably going to be bored first, but it's going to start making sense as the morning moves along, because you're going to understand that there's a lot of Ethernet devices in here, and that this is a secure operating environment. So it's more than just a big metal box that turns lights on and off. Oh, I forgot to put my picture of my Smash cabinet in there. All right, I'm going to have a bonus picture. I'll add to the addendum of the PowerPoint if you guys have already downloaded it. Saw a good picture of an ATC cabinet that took a big hit, but it was still operating. Speaking of big metal box, with ATC cabinets, actually, these are my cornerstones now in my career with all of the products that I work with in intelligent transportation. I ask myself, does this product or does this system meet these concepts? Safety, efficiency, and cost. Safety is how does this cabinet benefit to the safety of the system, the intersection, the roadway, the arterial network? How does it benefit to the safety? How does it improve the safety aspect of the intersection? This is why we're here. If we didn't have the chance of motor vehicle accidents, pedestrian strikes, just personal and property injury and damage, fatalities. If we didn't have any of that stuff, it's like Wired magazine that it comes out and says, "Oh, in 20 years we're not going to have traffic signals," or somebody on Twitter, X, says, "Oh, we don't need traffic lights anymore because I solved for that." Sure. Then we don't need to worry about it and we can all go home. But until that time, safety is our number one priority. We are literally managing people's day-to-day, everyday lives by working in the street. Next, number two is efficiency. This is the fun part. This is when we get to go out and install the new thing that makes traffic move better, or we put in the new timing, or hey, let's do an overlap, or change the sequence and the operation of the intersection. Oh, we can do that because we have more channels, or we have more of this and that. And then after you're done with your work and you put your tools away and you close your laptop, everybody looks at the intersection and they say, "Oh, wow, that's so much better." That's the fun part. Yeah. It's like that's why I wake up Saturday mornings at 5 a.m. and think about how to fix traffic in Maine or in California or wherever, because it's kind of fun to do that, honestly. A little nerdy, super nerdy, but it's fun. And then number three, costs. Factoring in the total cost of ownership of the system. Statistically, every time anyone rolls a truck, be it a contractor or an agency, it's $400 call out. It's $400 is what it costs that organization to send someone out there. If the state of Maine has to send someone from middle of the state, to Fort Kent to go work on a traffic signal that's in flash, because that's the on-call contractor. That's a couple hundred miles on secondary roads. That's an entire day's worth of call out. So if they send them up there and then they realize that they brought the wrong thing, or they didn't have all the information, so they can't fix the problem, so they have to either come back or come back with somebody else. That affects the total cost of ownership of the entire system, of the cabinet, of the intersection. Today, relevant to today, and I'm not going anywhere near politics, but let's just cut the crap. A lot of people are looking at a lot of costs. A lot of finance departments, a lot of budgets are under new scrutiny. So we have to be mindful of the total cost of ownership of the system. We can't just say, "Oh, screw it, let's just buy another one." That's not where we are today. I got into traffic back in 2011 by turning off phone lines after the recession. We had 6 phone lines running out to various intersections in Sevierville. They were formerly connected to traffic counters and stuff like that. Those little peak savers. We weren't using those anymore, but we were paying $100 a month for years for a system that we weren't using. We had to go cut the costs. That might happen again. So we need to be mindful about the costs of ownership of these systems. All right, so I'm going to kind of break down then those three key concepts. But first, I'm going to address the question that everyone always asks. Now, I've reframed this question. The original version of this question I couldn't use in this PowerPoint because it was more blunt and less polite. So I'll ask the question again in the Eric version. How is the ATC cabinet better than the previous generations of cabinets? Don't they all basically do the same thing, turning lamps on and off? Specifically, the original question was, why is it better than TS2? I don't see the point, was what was said to me. Well, let's talk about why it is better than TS2, why ATC cabinets are fundamentally better than TS2. First of all, and again, I have contractors and technicians in the room with me right now. Show of hands, anybody ever been shocked by a cabinet? Again, you guys on the internet, you can raise your hand. Yeah. Oh, Preston, even Preston's been, the IT guy's been shocked. Yes. You've earned your wings, buddy. Oh, yeah, he was a police officer too. Oh, even better. So, the ATC cabinet is the first platform built for technician safety, written into this spec. NEMA TS1, it's a death trap. There is over 100 exposed points inside of a NEMA TS1 cabinet in the early days. Now they started adding plexiglass shields and other kind of protective shielding. However, it's optional. You can unscrew the little thumb screws and get those panels out of the way. And if you forget to put them back in, the technicians in this room, have you ever taken those panels off and then not put them back on? I'm looking at you right there in the back, Chris. So like if the technician forgets to put those optional panels back on, then they've worked they've missed the point of the safety aspect. Inside of the ATC cabinet, everything in this cabinet is built with safety safety panels, safety protection inside the assembly. It's not optional. You can't unscrew it. I mean, you could prove me wrong and get in there with cutters and start cutting things out of the cabinet, but then you're just destroying the cabinet. But it's not an option. So every single PCB has a protective shield. All of the wiring connectors are now terminated in Phoenix connectors versus just crimp a little fork on the end and screw it down to the terminal. So everything is built for the technician because we do not want the technicians to be working in a dangerous environment. Don Moss, how much? What is the minimum amount of current that it takes to stop your heart? Only a few hundred milliamps is all it takes to stop your heart. So it's good that we build it. So we need to build a system that protects the technicians to the best of ability. Even things like the thermostat. I love this one because our ATC cabinets use a Stego plastic thermostat. But I've been shocked so many times just changing the set point on old NEMA TS1s where it's a little needle right next to the cabinet door switch, which is in the cabinet door, the cabinet light switch, which is just a door switch. So my fingers are reaching up in that little crevice and change that dial, and the next thing I know, my knuckle brushes against the AC of the light switch. Feels great. All right, another safety innovation: identifying dark signals immediately. So this picture is taken. You know this picture very well. This picture is taken about a block from Swarco McCain's headquarter office in Vista, California. You guys looking at this over the Zoom, the little red pin is our office, and then that little white pin on the road to the top center of that picture, that's where this intersection is. I took this picture in December of 2023. Is that right? Or 2022? Yeah, December 2023. I wasn't there in 22. So I went to the office. I live in Maine, so go to the office for a week every once in a while. I went to the office a couple times in the fall of 2023. This signal, you can see the left turn lane signal was out. And the question that I have, and then the reason I took this picture and added it to my presentation, and full disclosure, behind this Google Maps snip, yes, there's a second signal for that lane on the opposite end of the street, but it's not in front of the users, not in front of the motorists. So the question I always ask is, what color was out in that signal head? It's a dark signal, but it was what's on right now? Is it green, yellow, or red? You have to think about it, and for the people, for the professionals in the industry, and the fact that we know traffic, we know, oh, it's probably red because it's a left turn, and the opposite street has a green because they're going through the light. We know that. We know how traffic signals work, but not everybody knows how traffic signals work. So if the end user has to make a decision because the system isn't giving them enough information, that's the wrong answer, because it could be someone who's not paying attention, I always want to say like your grandfather or your grandparents or whatever, but like someone who just doesn't know traffic, and they're like, I don't know why it's dark, but screw it, I'm going to go. If they have to make a decision and there's a possibility they make a mistake, that's personal property damage, or even worse, a fatality. So the ATC cabinet monitors both current and consumed voltage output to the signal and current consumed by that signal. In a single signal scenario, obviously there's a second signal head for that channel. So this intersection in Vista doesn't count. But when there's only one left turn signal head and that red goes out, the cabinet should go to flash, and it should go to flash immediately. In a NEMA TS2 cabinet, it will go to flash after one service as a multiple indication, because it will see that the output voltage is still on. So in my perfect world, this intersection will have gone to flash if there was only a single red out, or single yellow or green out. And it needs to go to flash because it needs to say, hey, we got a lamp out here, come out and fix this. Now, we are just about there. We have one manufacturer of software, VDOT. You guys can benefit from this, greatly benefit from this. We have one manufacturer of local intersection control software, what runs on the traffic controller, that does non-critical lamp out monitoring. And what we have, that's the unlock that we've been waiting for years. It's a little embarrassing that we don't have it yet, but we're getting there. That's the unlock that we've needed for years, because what we want the central system to receive an alarm saying, hey, we detected that one of the colors, one of the reds or one of the yellows or greens on that channel is out. So we'll send a lamp out alarm, and then a technician can be dispatched. And yes, they might have to walk the signal to find out which lamp it is, but it's a heck of a lot better than a politician or calling and saying, you know, that green's been out for a month, or like Vista, California, where that red was out. I believe it was a red. I think I actually did watch it just to prove what color it was. But, you know, 3 months that red was out, you know. So the signal wouldn't go in flash because there's another red. But still, we all know that when the mayor sees something they don't like, they start calling the supervisors and the bosses. It becomes an emergency. So we have non-critical lamp out monitoring with one software, not ours yet. Ours is coming later this year. So we couldn't do that in a NEMA TS2 cabinet, because NEMA TS2 cabinet doesn't know that any loads being consumed by the signals themselves. Flasher alarm. This is my other favorite one. We're getting here. We're close to this too, I think. In a NEMA cabinet, if you remove the flasher, nothing happens. If you go to flash, nothing really happens because there's no flasher. The flasher module is the backup operation of the system, of the cabinet. Your cabinet's either running in colors, green, yellow, red, walk, don't walk, driven by the traffic controller, or if the traffic controller is offline or the cabinet monitor is just unhappy about something, the monitor de-energizes the flash transfer relays, switches the signal bus over to flasher operation, and then that little flasher with his little wig wags flash the signals. If the flasher is compromised or removed, then you don't go to flash. In a NEMA cabinet, the system, the monitor, nobody has any way of knowing that the flasher's out. The only mechanism that can tell you if the flasher is out is for the human to look up or to open the cabinet door and see if the flasher's there, if it's flashing, and if they want to test it, put it in flash and see if it goes dark. A show of hands, how many people have ever put a cabinet in flash and now realize that the flasher's out? Yes. Same with the internet, I'm sure. So the ATC cabinet can monitor the flasher. The flasher unit itself is a high density switch pack. It's not just some dumb Christmas light looking board with a wig wag circuit inside. It's the same high density switch pack that is driven by the output assembly. When it's inserted as a flasher, it changes operation, and it has 4 outputs, 2 amps each. It's also an intelligent device, so this flasher knows that that it's operating and that it's outputting, and it's getting a return from the flash transfer relays. So it knows that all of the cabling and the fuses and everything in the cabinet are fine. At that point, it turns the little blue lights on saying it's in flash, or showing the flasher outputs. If anything goes wrong with the flasher, the high density switch pack reports back to the monitor, hey, I got a problem. And then the monitor then can tell the controller via serial bus 3, which can then be polled by central. And then central can say, oh, hey, by the way, we got a flasher alarm at the intersection of walk and don't walk. So it is a very, it's a massive improvement because we're monitoring the we're monitoring the backup. We're monitoring the standby system. You know, there's 2 modes of operation of a cabinet, colors and backup. Now we know the state of both modes of operation. You know, we would never design anything in controls engineering or in anything. Aviation, we're having a lot of trouble in aviation nowadays. We would never design a backup system for an aircraft and then be like, well, we don't actually need to know if it works, so let's not set up any indicators in the cockpit. Don, you flew F4s. I mean, like how many redundant indicators do you have? Well, it's probably classified, but there's some, right? So flasher alarm monitoring is a massive safety improvement. Increased safety. Now, this is a Scott Evans slide. It's never leaving my slide deck. So other improvements for a fail-safer design, which is a Scott Evans phrase. Second bullet point from the top. I'm not going to read all these because I've kind of touched on all of these. Second bullet point from the top, the CMU output override. Again, another show of hands. How many people have ever put a cabinet in flash and the cabinet goes to flash, but it's also still running colors because of the main contactor is malfunctioned? Yep. Okay. Same with the internet. Raise your hands. So in a NEMA cabinet or a Caltrans cabinet with the old mechanical contactors, if the contactor malfunctioned, it was de-energized, but the contactor actually didn't change positions, you had a scenario where you ran flash because the contactor was de-energized, but you also were still coupled the controller to the signal bus. So the controller was still running colors. So we'd have a scenario where we'd have greens and then a flashing yellow or a flashing red, depending on the flash pattern. Dangerous and deadly. In the ATC cabinet, when the monitor becomes unhappy and wants to put the cabinet in flash, it de-energizes its relay output, shuts down the main contactor, and then also tells the switchbacks, hey, turn off your outputs. I had to yell into the microphone. And then the switchbacks administratively power down. We couldn't do that in a NEMA cabinet. The only thing that those load switches in a NEMA cabinet is 24-volt DC in, bridging to 110-volt AC out through the triac. In an ATC cabinet, it's the monitor saying, turn off your outputs. You're done. I'll tell you when you can turn them back on. Even if the main contactor were to malfunction, we would never flash and have colors running in an ATC cabinet. That by itself answers the question of why that's better than TS2. Getting a little intense. Next one, compact size and double density. Now here in East Tennessee, we have really 3 or 4 different variations of ATC cabinets, depending on which agency you go to. Sevierville, Tennessee, we put in a 352i in 2017. That's a single size, single rack cabinet. Looks a lot like the cabinet on the left. But now we were also putting in 350i and 353i's, where the cabinet it has a second bay. So by shrinking everything down, shrinking the critical operation, the critical assemblies down as much as possible, what we can do is have more space for everything else inside the cabinet. Because what are we putting inside cabinets now? We're putting in detection equipment. We're putting in Ethernet. We're putting in battery backups. We're putting in cellular. We're putting all of this other stuff. So we can shrink down the necessary space or the required space of the enclosure. As you can see from this picture here, I have at the top a McCain controller in both of those cabinets. On the left, it's a 332 cabinet, 18 channels of output and 20 or 48 channels inputs. So below the controller, those 2 racks, those are my input files. It's 24 channels each, so it's 48 inputs. Below that is my power distribution assembly, where my flasher and my cabinet power supply are. And below that are my output and auxiliary files. 18 load switches in the monitor. So on the right side, I still have, below the controller, I have 2 rows of inputs, 24 channels each. Below that is a 16-channel output assembly. However, I got a trick that I can't do that's a little harder to do inside of a Caltrans cabinet. I can create, in a 16-channel environment, I can create virtual channels 29 through 32, and I'll talk about this in a minute. I'm gonna have to get moving here. I'm rambling. So with virtual channels, I can take unused colors from around the cabinet or from around the cabinet, maybe a PED yellow or maybe a like a flashing yellow arrow where the protected load switch. I'm not using the yellow and the red. I can end these unused colors and create virtual channels. Okay, that's kind of like IO mapping, right? Yeah, it is kind of like IO mapping, except one caveat. The monitor knows that that those unused colors were then bridged together to create channels 29 through 32, and the monitor monitors those as if they were a standard switch pack. So I really can take this 16-channel output assembly. If I have enough unused colors, I can then beef up and go to make it be a 20-channel output assembly. Try that in a TS2 cabinet. Guess what? TS2 cabinets, TS2 standard, the monitors only monitor 16 channels. It's hardwired. Your permissive card only has 16 rows for a reason. ATC cabinet, every monitor is 32 channels, even if it's a 16-channel assembly. Speaking of assembly, modular design. Now, this is an old slide, and this is obviously a very McCain-y slide, but this is how we can build different ATC cabinets. And I'll talk about this more when I get into actual agency level specs. LED signal compatibility. I hope we're done with incandescence. I know some agencies still have the yellows because they're only on for a quick moment. High density switch packs cannot drive incandescent lamps. The current consumption is higher than what the switch packs are rated for, and the nature of the incandescent filament ramps up and creates a demand spike that the switch pack can't account for. So ATC cabinets and incandescents do not get along. However, with ATC cabinets and the more efficient switching technology and the more efficient components, battery backup systems do become more cost effective. You're going to get more life out of your battery backups than you would in an old school NEMA cabinet that's full of ceramic load resistors and generating waste heat for no reason and whatnot. Another Scott Evans slide. This is just kind of a demonstration or kind of a showcase of how much we've changed even with LEDs over the last 25 years. Leveraging the benefits of power configurations. ATC cabinets, we have both high voltage and low voltage variants. Low voltage has not been widely adopted, and I completely understand the hesitancy because it's bigger than just a cabinet manufacturer and a component manufacturer to convert a city from 110 volt AC lamps to 48 volt DC lamps, because there's a lot of tech that's still in the street that requires 110 volt AC. However, as we get into more efficient cabinets, both high voltage and low voltage, we're getting more out of our battery backups. We also can then start looking at alternative energy sources. We have one solar cabinet deployed in the field in Virginia right now at FHWA testing ground. We have a solar cabinet deployed at our office. We put the panels on the roof, and we have 2 more solar deployments this year. All right. Now, that also doesn't take into account, I mean, solar, that's kind of extreme. It takes a lot of panels to put a solar cabinet out there, a lot of real estate. I mean, I'm not like a solar farm, but still, 15 square foot area, I'm guessing. Not every intersection can do that. However, we can have more efficient battery backups. We can get more out of our battery banks. We can use more exotic battery technology. AGM batteries, and I see a lot of AGM battery systems deployed in the Midwest. So battery backup runtimes can now be in days. Newburyport, Massachusetts, 2015, installed the first low voltage ATC cabinet in the Northeast, and that cabinet had 2 battery arrays. Basically, the second bay was just full of batteries. They wanted to see how long they could get it to run. Big winter storm hits, blizzard in March of 2015, knocks out power in the entire city of Newburyport. That cabinet ran for 3 days. I mean, it was a nothing intersection. It's a little New England intersection, so it's not like it's a Texas diamond or anything, but still, the cabinet ran for 3 days. That is pretty good. The alternative to having efficient cabinets, or is kind of what I'm showing, what my screenshot shows here, This is a hydrogen fuel cell solution. Now, I have a little bit of heartburn with this. If you've ever read the Jules Verne wrote a short story about the uses of burning hydrogen burning hydrogen and oxygen together. It's called The Fantasy of Dr. Ox. At the end of the story, bad things happened to the town because they were burning hydrogen in their lamps, and then they had a leak. So there's a hydrogen fuel cell technology we put on the street. So we put 5 or 6 of those hydrogen bottles, those full-size hydrogen bottles, in a 332 shell on the road, and then that's the battery backup system. Now, in a perfect world, this technology will power an intersection for 7 days. In a less than perfect world, let's see, who can I pick on here? Hey, Frank, what happens when a pickup truck hits a cabinet? Yeah, sparks fly usually. And I still tell the story of the Sevier County High School cabinet from 4 years ago. Well, we still can't figure out how that car had knocked that cabinet off the pad. If you put explosive devices, or if you put an explosive fuel source inside of a cabinet that can be hit by a truck or a vehicle, what do you think is going to happen? Good question. I don't want to see. I don't want anybody to answer that because I don't want to see what would happen. I think we can do a little bit better than a combustible battery source. I mean, we're all mad at electric cars because their lithium-ion battery packs can catch fire and burn. What happens when somebody hits a battery backup next to a school zone and there's an explosion? Anyway, probably going to make somebody mad in the industry, but I don't really care. Next up, virtual channels. Again, something like I said, we can't do this in a NEMA TS2 cabinet. Hey, let's make 4 more channels that the monitor can monitor. We're using all 16, but let's take some unused colors and make something monitored. Okay, cool. So all that is done through the monitor itself and the controller. All of our controllers in the industry today now support 32 channels. EDI's monitor supports 32 channels. So even something cooler, in a NEMA cabinet, you might have different variations of monitors that have different firmware. Oh, in order to get flashing yellow arrow, you got to send it back and have the manufacturer update the firmware because we bought this thing in 2005. Now, EDI monitors, they're all good for 32 channels. They all have this feature. You can't do that in just any old TS2 cabinet. Flashing yellow arrow setup. I love the NEMA flashing yellow arrow modes. I think it's mode A through, is it H, N, G? G and H are the most common ones for compact mode and everything. But in order to get all that set up, you have to wire the cabinet, configure the controller the way it's set up by EDI. In ATC cabinet, you can select any channel to be a flashing yellow arrow channel, any channel to be the protected if you're using a protected. But protected is also optional. Some agencies are just setting up constant flashing yellow arrows. We actually have one here in Sevierville that has no protected. It's just always flashing yellow arrow. Wonder who put that there. Must have been a lunatic. So any channel can be a protected or a overlap operation. More on the efficiency. ATC cabinets max out at 32 channel outputs. So that's more than a NEMA cabinet by 2. Yeah. So taking into account, hey, we have a platform that has twice as many outputs. That doesn't just mean that we can build all the diverging diamond interchanges and all the big complex intersections we want, where we have 3 or 4 physical traffic intersections slaved back to one cabinet, which is fun to do, but it's also terrifying to put those in flash. Some intersections just need more. We have intersections now with flashing yellow arrow left turns, flashing yellow arrow right turns, right turn overlaps, bike lanes, blank out signs, you name it. We're adding more signals, queue jumps. We're adding more signals and more things, even if the intersection isn't a gargantuan large intersection. We're starting to hang more signals in the air. We need more channels, and we can do this with auxiliary I/O. I mean, the city of San Jose, California, their previous spec for light rail was a 24-channel TS2 cabinet. Guess what? They're still only monitoring 16. That's why we now build a 32-channel ATC cabinet for them for their light rail. But you know, we're still stuck at 16 monitor channels. And then from there, we can get clever with controller I/O mapping and logic gate. You can use logic gates. Um, but in reality, this is the way to go. And of course, bringing in 120 detector inputs into the cabinet. If we need more outputs, we're probably going to need more inputs to turn on those more outputs. So some examples of complex intersections. This is a 32-channel ATC cabinet located. If you see where that vehicle is turned in the, I really need to label this slide. There's one ATC cabinet in the middle of the intersection. This is two intersections with a bunch of PET overlaps with light rail going through it. And we need to be able to run this intersection in limited service when light rail is passing through there, which happens every 10 minutes. So we used one intersection, one ATC cabinet. We used all 32 channels in order to drive this intersection. This one's a little closer to home for me. This is South Portland, Maine. So this is, I'm going to talk more about this particular intersection later on. This is a single cabinet running two intersections. The intersection on the right at Broadway in Maine has PET operation. And then the intersection on the left is just overlaps driven off of the intersection on the right's vehicle phase operation. It was more efficient to put this in as one cabinet so we didn't have to worry about synchronizing between two controller clocks and everything. And then the last, I think this is the last for the guts of ATC. The last feature of this is both cost efficiency and, to me, safety. Decoupled service assembly. So the picture on the left came from Fort Worth, Texas. A proud Texan really went, you know, that's what they do down there. I asked them why they do that, but you know, they're like, it's Texas. You know, people like to shoot cabinets. They like to shoot anything. So this cabinet has suffered multiple gunshot wounds. Now, in reality, that cabinet's likely still in flash because the service assembly was not likely to have been hit. And in that case, let's say the city of Fort Worth didn't have a spare cabinet. They just used their last cabinet and they needed to get this one up and going. They could cover those holes, replace the assemblies that have been damaged, and bring it back out of flash. But in the meantime, while they're making the repairs, and I'll talk about this in a moment, the cabinet's staying in flash because the service assembly is undamaged. So the service assembly is where the flasher system is maintained. So everything else, everything north of the service assembly, everything north of this little box, you can turn it all off, rip it all out. Cabinet's still running in flash. So it is a massive benefit. There's no way you could do that in a NEMA cabinet. If somebody shot the cabinet and penetrated the back panel, you're changing that cabinet. No one's going to try to fix that back panel. No one's going to even try to fold that back panel down to fix it while the intersection is still in flash. You're powering down and either deploying officers or stop signs. In the ATC, you have more options on how to service these cabinets. All right, so let's talk about some improvements here. Actually not doing too awful on time. So we're up, if you want to think of it like Iron Man armor, we're up to our Mark 6 or Mark 7 ATC cabinet design. The cabinet here is a 2014 or a 2015 build of ATC. That's our Mark II cabinet, actually. And I can say that confidently because I've seen the Mark I. The service assembly is different. But this cabinet here, this dusty old thing, used to live in my office when I worked in Sevierville. Really good white noise generator for your staff. Preston, you wouldn't have worked for me, but you know, it comes in handy. So this cabinet right here is mostly, that would be a Mark II ATC cabinet. And we could put it in the street right now. I wouldn't want to because, well, we can do better. Now, that's the thing with Swarco McCain. That's the thing with how we've improved our ATC cabinets. We answer the call to keep improving these cabinets, assembly by assembly, layout and design by design. Someone says, "Hey, here's an idea." We run with that idea, and we vet it, and we typically implement it. So let's kind of go through this. So again, I said this earlier. This is all we had to work with from the spec, from the standard. You know, okay, this is how you build an ATC cabinet. All right, cool. Well, that one's mandatory. That one's optional. All right, well, let's get to work. So this is more of our marketing slide. We started using this slide in 2014, 2015 to start preaching the message of ATC. I've sat in on these presentations back when I was here in Sevierville. You know, Don, actually, we were just talking between Don and Ayrton. You came and you used that slide, I don't know, 9 years ago at the National Traffic Research Center in Oak Ridge. So this is a cute little way of labeling all the cabinet components and assemblies and such. However, my regional sales manager in Midwest, Tony Jutner, he actually, we did a presentation last year and he said, you know what, I got to be honest with you. I hate that slide. Can we do something else? And I thought, yeah, that's right. I mean, we've been using this since we've started marketing the ATC cabinets. And actually, this is a funky slide because this controller here with that giant screen, that's a LA City controller. All right, so we've been just like showing everybody this slide using the graphic for a prototype cabinet we built for LA City. So we can just say it's seen its day. I like to show the assembly labeling and everything, but let's show what we're actually doing with ATC cabinet layouts and such. So what I want to do is I want to show you 4 different cabinets that are the same build. They're 4 different 350i cabinets. But I want to show how each agency is deploying this technology or acquiring this technology to suit their needs, not just, oh, let's just go to the car lot and buy a blue car. Oh, what kind of car what do you think? I don't know, man. It's got to have 4 doors and a wheel. I don't care, So first off, may as well, because I'm right here. This is the Sevier County spec 350i ATC cabinet. This is pretty much a stock ATC cabinet with a different layout. So we build 60-inch tall cabinet, two full racks, but then we rearrange the assemblies, placing the input and output assemblies, the auxiliary display unit, everywhere where Sevier County agencies, so Sevierville, Pigeon Forge, Gatlinburg, and Sevier County, that they all agreed and they said, this is where we want everything. We want the batteries on the right. We want shelves here. We want the auxiliary display unit to be right above the monitor because Gary Reagan likes to look at the auxiliary display unit right next to the monitor, which makes a lot of sense actually, because he's an old NEMA guy. So I mean, what do? You touch the monitor, you push the buttons. So the auxiliary display unit being kind of like the monitor, or it is the monitor, it's the eyes and ears and fingers of the monitor. He wants it right there, right next to the reset button. Makes perfect sense, Gary. Next up, close at home for me now, State of Maine DOT. Again, 350i, so 60 inches tall, 2 racks. Now, Maine places a technician panel on the inside of their door, and they put the police panel on that same door. So they're old school NEMA. They like having the technician panel down to the controller power switch. So they said, I want a controller power switch. Okay. I said, doesn't the controller already have a power switch? And they said, not all of them do. Oh, that's right. Yeah, and a Econoline Cobalt doesn't have a power switch, but a McCain ATC or a Q-free NEMA controller. I never learned their model numbers. They all have power switches. So yeah, let's put a controller power switch on it. And then of course they have their own custom layouts. They also have one of the coolest coolest assemblies in ATC world. It's called the SLR, the slide lateral rack. Although Joe Herr from VHB admitted that is actually the Steve Landry rack. So this is a storage rack for spare parts. Going back to this scenario where Maine DOT has to dispatch the on-call technician to go work on the traffic cabinet 150 miles away in Fort Kent. They get up there and they realize that they forgot to bring a spare monitor and the monitor was bad. Well, that's why you have a spare parts rack inside the cabinet, because we have the monitor ready to rock and roll. Pull it out of the spare part, put it in, and off you go. For agencies that buy or that want to invest in the card storage rack, good news. And maybe we're all following fair purchasing laws and everything. This is not a McCain proprietary part. State of Maine has 4 different makes of ATC cabinets in the state that are approved by Maine DOT. So Swarco McCain, Mobitrex, Econolite SafeTran, and Cubic Trafficware all build this style cabinet. Again, a little bit differently. The assemblies don't interchange, but they all have this innovation like the card storage rack. Now, if you do invest in the card storage rack, do me a favor. Don't put bad parts back in there. Okay, I've opened up a couple cabinets in Maine where the switch packs are written on there bad. Okay, no. First rule of IT, Preston, you never worked with me, but you can ask your colleagues. First rule I do in IT from my IT days: if it's bad, break it. Okay, if a high density switch pack, or maybe not switch pack because those have to be RMA'd, but if there's something in the cabinet that cannot be serviced, put it on the ground and stomp on it and then throw it away or send it back and RMA it. Do not leave it in the cabinet. Get it out of there, and because otherwise the person who comes up behind you and maybe they can't read your writing that's when it says bad, they'll take that bad switch pack and they'll put it back in, and then they'll waste an hour troubleshooting a part that they thought was known good, but it actually turns out to be bad. All right, next up, MnDOT, Minnesota DOT 350D. I don't know why it's a D and not an I, but they also have blue flash program blocks for no flash. I don't know why they do that either. So this is their custom layout. Again, 60 inches tall, 2 racks. Now they have a fuse assembly because in Minnesota, they divide their loads for each channel output. So they fuse all of their loads, and if they have, for example, if they have 4 greens, 2 of those greens are on one fuse and 2 of the other 2 are on another fuse. So they have this custom fuse assembly to protect all of their outputs. And we'll talk more about fuses in a minute, but this is a really cool cabinet. And then West Des Moines, a low voltage cabinet. Again, 60 inches tall, 2 racks, laid out the way West Des Moines likes them. And then, of course, they have battery backups. They have detection by GridSmart, Clary battery backup unit and such. So they say, hey, we'll send you the parts. You put it in there for us. So we make improvements based on our own internal feedback and your feedback. So first improvement I'm going to talk about is the output assembly improvement. We've moved the main contactor on the 16-channel output assembly to behind the little door. Can you help a brother out here? So this little service door, I turned it off because it's high voltage back there. There's 4 isolation circuit breakers, each one protecting a pair of switch packs. What we found is that those isolation breakers don't exactly protect the switch packs. So we've removed all but one of those, which is all the standard calls for. And now we've moved the main contactor, which is buried behind, way in the back of the output assembly. We moved it back here so you can get to it. Because the technicians kept saying, I hate your output. I hate having to pull the output assembly just to change the main contactor because you cannot get to it. Okay, so we moved it. We made it easier. We've also placed spare fuse holders for our new fused field output termination assemblies. So spare fuses inside the cabinet in case those fuses blow. I'll talk about that more in a minute. A new service assembly design. This is a little bit of an older slide. This is actually from the 2024 deck. We have now spare fuse holders for the high density flasher unit fuses because everybody says, hey, can we get some spare fuses for this cabinet? Sure, I'll put 4 right here on the front of the service assembly so you guys can easily get to them. The other thing we did was we put USB ports on the GFCI outlet. I do not want you plugging your cell phones into the traffic controller. I don't care whose controller it is. Don't plug your cell phones in when you need to charge because you're on the phone with tech support or you're on the phone with the installer, and you realize that your phone battery is low. Plug it in to the GFCI outlet USB ports. The reason I say that is these are smart devices. This traffic controller in the cabinet is a Linux-based PC. You don't have to move it. So when you plug your iPhone or your Android phone or well, I was going to say BlackBerry, but they're gone. Rest in peace. When you plug your iPhone into another intelligent device like a Linux-based PC, the first thing that happens is Linux says, "Oh, hi, who are you? Oh, let me read your file system. Well, let me hold on a second. Let's mount you up here. Let's do some stuff. You know, whatever the USB driver says. I don't want the smartphone to ever set up a scenario where it compromises the traffic controller, even if it just locks up the traffic controller. Oh, cool! I plugged in my phone because I'm on the phone. I'm on the phone with tech support. I'm talking to Eric right now, and he's telling me how to program the traffic controller, and we're just about done with coordination. Oh wait, my battery's low. We plug in. Oh, the traffic controller just locked up, and we didn't save the database. No, plug into the GFCI outlet. We don't have to have a relationship between your smartphone and the Linux-based controller or anything else in the cabinet that has a USB port. Grid Smart processors or a MyoVision processor or a no trafficker, Nexus is what those are called. No trafficker, geez. So like plug it into the charging power port. Very, very minor, very simple thing, but hey, it matters. This is the wrong graphic. I've still yet to get the graphic for this, but in our low voltage service assembly assembly design, which we don't have any low voltage cabinets here, we put a backup power supply inside that low voltage service assembly and another flash transfer relay. In the original design, when the cabinet lost 48 volt DC, which is driven by the cabinet power supply, it would lose flash because the cabinet power supply is the power source for even the flasher. So what we did was we put a backup power source inside the service assembly. So as long as there's still utility power going to that cabinet, if the main cabinet power supply dies because ants got inside of it or whatever, then the backup power supply will at least drive the flasher system. That was an Achilles heel that we solved. We gave it an LL Bean boot. I like that actually. This one actually is one of my favorites, and this has been talked about before, but I cannot stress this enough. I'm going to work with Sevierville to buy a few of these in general to upgrade some of their spare cabinets, make them more viable. Fuse field output termination assembly. So the high density switch pack is relatively expensive compared to a load switch. Load switches are 20 or 30 bucks. These are, depending on the number of times EDI has been sold lately, they're between $200 and $400. I think they're pushing $400 now. So the load switches were rated for to power incandescent lamps, so 10 amp output per color. High density switch packs are rated for LED lamps, so 1 amp output per color. If there's an event at the intersection, a knockdown, a shorted wire, somebody plugs in an incandescent because they didn't mean to, and the switch pack fails, that's expensive. Let's go back to total cost of ownership here. I have an agency in the Northeast, and I won't mention any names, but they're the ones that gave us this idea too. You know, lovely city. They have no jokes. They have technicians, or they have intersections where PED poles are knocked down every week. Same PED poles. All right. Engineering won't move the PED poles, so the construction guys just have to go and put them back up. So every time the PED pole is knocked down, shorts the switch pack, blows the switch pack. Now there have been circumstances where the technician, maybe they're new, they go out there, they fire up the cabinet, or they open the cabinet door, they're in flash, they look at the switch pack, they see the bright blue light on the switch pack saying it's bad, then they change it with a brand new switch pack, not realizing that the PED pole was knocked down. So plug a new switch pack in, hey, we still have a field short. Oh, I must have had a bad switch pack. Let me try again. 2, 3, 4, 5 at $400 a piece. Do the math. So they said, can you put a fuse on this thing? I said, no, it's not ours. This belongs to EDI. But what we can do, put a fuse on the backside of the field output termination assembly. So our new series field output termination assemblies now have fuses, 1 amp fast blow fuses, protecting each channel color. So now, when that city has a knockdown, the switch pack's fine. The fuse blows. And then they say, oh, that's something else for us to check. And I say, what's the lesser of two evils? There's a knockdown, the switch pack fails, you go to flash, maybe it's a knockdown of a signal, of a flashing signal, not just a PED pole. So you have a knockdown, switch pack fails, and there's still a short in the field for the signal head. Maybe maybe a bird's nest or whatever, you know. So then there's an active short on a channel that's flashing. So then every time that now the flasher fuses and everything are damaged by this short, and as the problem is cascading through the cabinet, or you just blow the one fuse. Which one's worse? And I will commit traffic aside if I find anybody ever putting copper wire in those things, as if, you know, back in the old school days, you put a penny under the fuse. I don't even know what traffic aside means, but I will invent it. Now, the cool thing is, this is just for us, so I'm gonna be very, very clear. For Swarco McCain cabinets, these new assemblies are retrofit ready. So this vintage 2015 cabinet, if Joseph calls me and says, "Hey, I want to put that in the street," then I say, "Buy this assembly and let's change it out." These new fused output termination assemblies can go in existing cabinets, even the cabinet number 1 in Cedar Park, Texas. All right, next improvement. This one was fun, actually. This is called the auxiliary input-output assembly. So, Ayrton, can you look at my cabinet again, please? So if we want cabinets, if we want to use any auxiliary I/O in this stock cabinet, we have to run the I/O field wiring through the input assembly, or push outputs through out of the output assembly using the switch pack. Unlike a NEMA cabinet where there's extra I/O coming through the ABCD connections, we don't have that inherently built into the ATC cabinet. So we came up with this auxiliary I/O assembly. 21 inputs, additional inputs, 8 outputs. We have a breakout panel for cleaning up field wiring. And what this does is the controller can then use logic or other functions to turn on these outputs, but wire into different inputs. So Minnesota DOT, they use it for police panel monitoring and rain sensors and weather sensors, battery backup inputs, all of the extra things that we would want to bring into the traffic controller, we bring it in here. Ames, Iowa is actually, we sell a little insert. It's a little sticky insert. It's like a heating pad for the inside of the traffic signal head hood. They're putting these heated inserts inside of their reds at intersections, and they're turning the outputs on through the controller. So they're bridging raw power, turning on those heated inserts. So when it snows during a snow event, there's not a snowpack inside that signal head. Again, safety. And they can actually do it from their central system. So they're going into transparency and saying, "Oh, it's going to snow for the next 12 hours. Click. And then they turn on the heater inside the signal heads, all driven out of the aux I/O assembly. And what this lunatic did in coastal Maine during Halloween, hey, that's my jacket, is I took my low voltage shop cabinet and a bunch of low voltage lights, and I lit up my house, and then using the aux I/O assembly, I made a little button for the kids. You walk up there, they push this button, and it triggers a logic gate, which sets up a Canadian fast flash in a kind of a lead lag, like stair step kind of mess. Oh, you know, so they could turn the house into haunted beast mode. You know, just having a little bit of fun with some of our own technology here. But this assembly is very, very, very useful, and I'm seeing it adopted more and more. Anywhere where we need extra I/O, we don't want to use a switch pack or the input rack, we can use this. Input test switch assemblies, for those in the NEMA world that missed their test switches, we have them. TS2 SDLC bus. So the ATC cabinet serial bus is a 25-pin serial bus, and it has SB1 for the ATC cabinet comms and SB2, which could be used for TS2. But a lot of agencies are like, you know what? Can I just have my old TS2 bus so I don't have to get wonky cables or anything like that? I can just keep up with what I need. You know, same old cables I use in my NEMA cabinets. Yes, we can just install a TS2 SDLC bus. Most of our cabinets we build for agencies in Texas, and every agency in Texas has a different spec. Hard specs this SDLC bus. So we have 2 serial cables coming from the controller, one to the SB1 and another to the TS2 SDLC bus. And then everybody gets along. Hey, if the detector box needs to connect to ATC cabinet serial, it can. If it needs to connect to TS2, it can. No problems. Bus interface units versus serial interface units. So what are we up to this year? A lot of everything I showed you was kind of culmination of 2023, 2024. Let's talk about what we're doing this year. We're not doing anything super fancy. We're not putting laser beams and radiation shields on these things, but we are making it easier for the technicians, for the agencies. Caltrans came and is looking at ATC cabinets at our office, and they had a list of things what would be great is if you guys did this. So we're like, oh, that's really good feedback. So let me talk about some of the stuff that's coming down the pipe. The first one, and I apologize, I can't show you the picture because I don't have one, but we're rethinking the flash program blocks. You can see the picture on the right here. I have 3 flash program blocks: red for red flash, white for no flash, yellow for yellow flash. This is how we set the flash transfer, or the FTR flash pattern. And of course, the tool below there is pretty much the necessary tool to pull and change those things, because they're a pill to get to. They're tiny, and once the cabinet goes through a season and that plastic Molex connector is heated up and whatnot, they're just kind of stuck in there. So I always have to use pliers to pull them out. They're also handmade, so we are having to source the Molex connectors, cut the leads for the yellow, red, and white wires, and then crimp the little ends in there, and then put the wires in the pins. There's a better way to do this, a much better way to do this. Our next generation field output termination assembly, our flash program blocks are going to be a single piece. It's a silicon wafer, a red, white, and yellow. I was going to say blue. Actually, we will have to have blue from INDOT if they want to go down that road. So then it's just a wafer. It's a silicon wafer. It's almost like the forks in a NEMA cabinet. You have those little insulated forks that where you have to insert the forks in the channels that don't have load switches. So I say I can't talk about it that much. I don't have any pictures on it yet, but this is what's coming this year. Next, field wire management. So I think it was Caltrans that came up and they said, after you start wiring the ATC cabinet and you start bringing your wire up the side wall, up the side of the racks to your output assembly and your input assembly, it gets really kind of messy. Can you guys do something? So what we're doing is we're folding metal a little differently. We're giving each assembly our kind of wings that protrude out to where we have better wire management as we're bringing these harnesses up the side of the cabinet rack. That makes it so much more cleaner. What we're also doing, and I don't have any pictures of this, those thumb screws that we put on the back side of the output termination assembly and the input termination assemblies, you unscrew the thumb screws and you can fold the panels down. Like for the output termination assembly, that's where the fuses will be, and that's where the surge blocks are. They're a pain in the butt. I don't know, our guys at the factory, they really torque them down. So you typically, you're like, you look at it and you say, oh, it's a thumb screw, so you can just unscrew it. In reality, you're going to get a screwdriver because they're really torqued down. We're coming up with a quick release mechanism for that. It'll be a metal mechanism, but we're getting rid of that thumb screw because people don't like it. More I/O termination for devices. So if you look at everybody here in East Tennessee's cabinets, for sure, but even everybody in the Zoomerverse, the output assembly, the input assembly has 4 little switches all the way to the left. Optos 1, 2, 3, and 4. People always ask me, hey, what are those used for? I say, whatever you want. We don't program those by default. So these are just option switches. Those are the last 4 inputs on that SIU, but it's not landed in a slot, nor was it previous to now landed so where you could bring your field wiring and interface with those opto inputs. In NEMA TS2, the 4 opto inputs on a terminals and facility BIUs were used as the PED detectors. So PED isolate, it's an isolated input. Now what we're doing is we're rebuilding our field input termination assemblies, or redesigning them to include the optos on the backside. So now you could wire in your PED push buttons in as opto inputs and not have to use a 242 DC isolator. So this is a lot like, this is parity with a NEMA TS2 cabinet, the NEMA TS2 Type 1 cabinet, excuse me. And also the aux IO assembly that I talked about earlier with the Halloween lights and everything. There's a breakout panel that you can put on the cabinet sidewall that will you can land your field wiring into that if it's coming in from the field, maybe like from a blank out sign or something like that. Okay, troubleshooting and how-to ATC cabinets. Oh, I'm way behind. All right, so I want to talk about how far we've come. And then I'm going to kind of go through this real fast because this is the part. The City of Philadelphia asked me to write this presentation, and this is more valuable in a take-home form because I'm not going to sit here and read all these slides to you. So we will probably take a break in about 10 minutes. This is an entire presentation by itself, but trust me, a screwdriver and some wire cutters. So just kind of a recap. So the cabinet here in this picture, this is cabinet number 1. This is the Cedar Park, Texas cabinet. Still running. We've upgraded it with 2 switch packs. That's it. And they've added like detection and such. So we have over 8,000 ATC cabinets deployed in North America. That's 10.5 years worth of progress because we installed that cabinet in September of 2014. Yeah, September of 2014. Now, 8,000 cabinets doesn't sound like a lot, but we aren't exactly Ford Motor Company here. We're not cranking these out in an assembly line with robots building cabinets. Nobody in our industry is doing that. So 8,000 cabinets, that's a lot of metal boxes to be built by 5 manufacturers. So we're now building more ATC cabinets than any other cabinet type. I mean, which is saying a lot because we're based in California, but we aren't building as many Caltrans cabinets as we are building ATCs. Of course, we're making our improvements, and of course, Swarco McCain is committed to training and education. Don and I are standing right here, and we do this multiple times a year. I'm proud to say, and this is kind of a bold claim, but I can back it up. Swarco McCain has 85% of all of the tribal knowledge of ATC cabinets under its roof across the industry. So cabinet improvements. So I talked about all these already. I want to talk about this little retrofit example. I did this in December, South Portland, Maine. So I talked about this intersection earlier. The 32-channel ATC cabinet running 2 intersections with PEDs and whatnot. So this was originally deployed July 2022. However, 2 weeks after the cabinet was deployed, there was a wreck and a vehicle struck the riser next to the cabinet, struck the pole next to the cabinet, crushed the signal cable, shorted out the cabinet, shorted out things in the field, and the contractor didn't notice that the wiring was damaged. So the cabinet started to develop gremlins. So it was starting to blow, switch packs were starting to fail. Channels were randomly going into fault, and the technicians were starting to have to like move switch packs around and remap things in the cabinet to find available slots that were good. So we finally talked the city into fixing this cabinet. So they bought a new output assembly, they bought a new service assembly, they bought new fused output termination assemblies. So if this happened again, the cabinet would blow a fuse instead of being damaged. We changed all of those parts out in 2 hours. The cabinet stayed in flash until the contractor said, hey, we're going to fix some field wiring. So they started pulling cable. Then we had to go dark. So I want to be full disclosure there. But the repairs to the cabinet themselves were done in less than 2 hours. And with the exception of changing the output termination assembly and the service assembly, which is really 2 guys, 5-minute task, 10 minutes maybe, the cabinet was in flash during the rest of those repairs. So in a NEMA cabinet, and you guys can't see this here in person because there's a zoom bar here, but you're not making this repair in a NEMA cabinet. You're changing the cabinet. If the back panel's smoked, that's it, you're done. We here in Sevierville in December of 2017, that's why we have an ATC cabinet now. That's why we installed our first ATC cabinet, because the back panel was smoked. It was an old transit printed circuit board cabinet. Rest in peace, Hal Labatt. I saw that on LinkedIn this morning. Hal Labatt, founder of Transit, which was acquired by Peak. Yeah, lost another good one. So that was an old Transit cabinet with a printed circuit board. The cabinet took a hit. Actually, it was the cop's fault. You guys, you guys put it in flash for a freaking Santa road race, and then you brought it out of flash, and that back panel gave up. So then, there's no servicing it. We spent all day out there. We couldn't figure it out. So we called Transportation Control Systems. They brought over an ATC cabinet, and the rest is history. You can't fix a NEMA cabinet like you can fix an ATC cabinet, unless it's been, the common denominator is if they're both hit by a truck, then they're both done. All right, so let's talk about troubleshooting. Boy, I have a lot of content here. Troubleshooting concepts. Number one, start from the top. Start at one end of the problem or the other. And what I mean by that is start from the monitor and the auxiliary display unit, or get your bucket truck and go up and look in the signal heads. No, kidding. Start from the auxiliary display unit, which is always at the top of the cabinet unless you're in Pigeon Forge. Start from there, leveraging the modularity ATC cabinet. The auxiliary display unit will tell you what's wrong with the cabinet. Also, look around. Agencies, the one agency I was just talking about that just keeps changing the bad switch pack when the intersection's lying on the ground. Look around, make sure that everything's intact. And then get the logs. I'm going to stress on that. When in doubt, get the logs. We are blind. Don and myself are blind without troubleshooting and diagnostic logs from the controller, from the monitor. You call me and say, I got a problem with the cabinet. It was in flash. What was the fault? I don't know. I'm not out there. Send me the logs, because the monitor logs are gold, and I'm blind without them. So this stupid graphic again, this graphic again. All right, troubleshooting. Start with the auxiliary display unit. The guys in Philadelphia have a saying. They say blue is bad. So when the cabinet's in flash, look at the ADU. The ADU will have a blue call out for all of the channels that are contributing to the fault that the monitor saw. Only turn those blue lights on under normal operation when it's in flash. Now you can push buttons and view various stats, and that blue light is an indicator saying, hey, this is what you're looking at right now. But from the home screen, when you have blue lights, that means that those are the channels that are causing the flash. The auxiliary display unit is also a mostly harmless device. You cannot program the monitor. Unlike a NEMA cabinet, you cannot program the monitor by pushing any of those buttons. So do not be afraid of that device. The only thing you, the technician, can do to the auxiliary display unit is clear the logs, okay? No big deal. But use, do not be shy and navigate through the auxiliary display unit. Also, the diagnostic wizard, the help button, Scott Evans himself. You push the help button. EDI is coming up with an acronym as for their firmware. It's the more better wizard. The help button launches the diagnostic wizard. When you're in flash, you push the help button, and it will start to define the fault types. All right, it'll give you the definition of what the fault means, and it'll start telling you what to check. So the first page always gives you a definition. You push next, and the next page tells you what channels and outputs were detected in the fault. And as you're pushing the buttons and going next, the lights on the ADU are changing because it's narrowing down to the scope of the problem, down to the one light that didn't come on, the one color that didn't come on a channel, which contributed to the field check fault or the lack of signal fault. And then other pages, it may have some other information, but the help wizard by itself is as good as gold. So here's an example. So lack of signal fault. You push help. It says no signal color is active for these fault channels. Scott's pointing at the ADU. Look at the blue lights. Next screen, output voltage is active, but no load current is active on these outputs. Again, it's telling you that those outputs didn't light up, or it saw voltage, but it didn't see any current. And then the next screen, here's what to check. Check your field wiring, check your flash transfer relays and everything. So it really is super helpful to use the help screen because it tells you how to troubleshoot the cabinet from the monitor's perspective. Now, every once in a while, you got to go into the controller because the monitor doesn't see the big picture. The monitor is only, well, it's monitoring the cabinet, so it has a very narrow view of expectations, whereas the controller might have been programmed to do something wonky. So I'm going to blow through these slides. This is for the take-home version. And if you've ever sat through my ATC cabinet, this is all going to look very familiar. So with the city of Philadelphia, I wrote these different scenarios to kind of ask a question of how we, what is a serial bus 1 error or what is a lack of signal fault, and just kind of work through the thought process. So after each one of these troubleshooting scenarios, I have, of course, the troubleshooting diagram. Is this on? Is that on? Whatever. The one takeaway I have as I blow through these slides, that I always start at the ADU. Don't cut the corner. Don't just go look at the switchback. Always start at the ADU. That's how you troubleshoot an ATC cabinet. CU latch fault. This is the only one that doesn't have a troubleshooting diagram, because CU in this case stands for controller unit. A CMU is a cabinet monitor unit. Now, if the monitor says, hey, the controller is latching a fault, that's basically the monitor going, not my job. The controller's not happy. I don't know. Ask the controller. So again, ask yourself, what would cause the controller unit to latch a fault? Are there status screens to help? Yes, we'll talk about the status screens in a second. Or did anybody make any changes to the controller programming right before it went to flash? Hey, maybe we were adding an overlap, but as soon as I programmed the overlap in the controller, it went to flash. That's a clue. Remember, the controller and the monitor talk. They're very gossipy. Lack of signal fault. This is again just kind of thinking through what causes a lack of signal fault. So we have again, starting at the ADU, our troubleshooting diagram. Now, I throw this up scenario for lack of signal fault again. This is the one fault in the ATC cabinet that could have different root causes. So if you get a call and say, oh man, I'm out here and it's in lack of signal fault, don't just say, well, change the switchback. It's going to be the switchback. It could be multiple root causes, even down to the way the data key is programmed. So bear in mind, and I leave this in here because I want to say lack of signal fault can mean multiple things. Oh, the cool thing though is when you push help, the monitor, the diagnostic wizard will actually help dial you into the actual fault type that's occurring. So if it's a lack of signal fault because of the way the data key is programmed, the information that the diagnostic wizard will give you will steer you to the data key. It won't just say, oh, go check your field wiring. Serial bus 3 faults. Serial bus 3, as a reminder, that is the serial bus that the monitor uses to communicate with its switchbacks. If the monitor loses communication with any of its switchbacks, it'll immediately go to fault with the serial bus 3 fault. In a NEMA cabinet, you could pull a load switch and you'll get a red fail. But then you could put a jumper in there and just bypass that terminal. In an ATC cabinet, if you tell the monitor to expect a switchback to be in slot 4, by God, there better be a functional switchback in slot 4. Otherwise, you'll get a serial bus 3 fault. Flasher alarm active. The one thing about flasher alarm, cabinet won't go to flash if you see flasher alarm on the ADU. But again, here's how you troubleshoot it. You always start with the ADU. 24-volt DC failure, which is exactly what's happening in this old cabinet right now. We're going to fix it during lunch. That's how we troubleshoot that. Again, more offline. I'm going to blow through these and not read them all out loud. What all of the switches do inside the cabinet. Now, these are defined by the ATC standard. So this information travels across the manufacturer boundaries of Swarco McCain and Econolite SafeTran and so on and so forth. Circuit breaker guides, what the circuit breakers control inside the cabinet. And finally, this is kind of a walkthrough of what you can take apart or what you can turn off inside the cabinet and stay in flash. So this next section I wrote, and again, I'm going to blow through this, replacing the assemblies. Philadelphia wanted to know how I would change the cabinet you know, or how I would pull cabinet assemblies out, and replace them, and what the operation is. So this next part, I couldn't write until I actually got an ATC cabinet shipped to my house, which happened last year. And then I spent 2 days documenting exactly how you would take the output assembly out or the input assembly. So I kind of wrote it like a Chilton's auto repair book, you know, down to the most annoying part of that of an automobile repair manual is the last step is always installation is reverse of removal. Okay, cool. And turn the book upside down and I'll just put it back together, even though I forgot where this screw went. The DeLorean user manual was the worst because it was British. Actually Irish, so I mean, I think step 3 was always pound a Guinness. So I have in this section replacing each assembly, starting with the ADU. Now, inside of this assembly also, I also state if the cabinet needs to be in flash or will go to flash, or if you need to put up stop signs or contact police for intersection operation. So we have ADU, tools required. Now, this is also a clue. This is pretty much all you're going to need for any of these, except sometimes you need a wrench. Phillips head screwdriver, precision screwdrivers for the little Phoenix connectors. Replacing cabinet power supply. Again, if the cabinet power supply is out, then you're already in flash. Tools required, Phillips head, precision head screwdriver, Phoenix connectors. Cabinet serial bus, DC power and clean bus assembly. Oops, too much. So this is going to vary between age of cabinets and also cabinet manufacturers because Mobitrex and Swarco McCain and Econoline Safetran all have a little variation of assemblies, but for the most part, it's the same idea. Phillips head screwdriver, precision flathead screwdriver, and maybe if you have zip ties, snips, cut the little zip ties. Now, taking that assembly out, we'll place the cabinet in flash. Input assembly replacement. It doesn't necessarily put the cabinet in flash, but you might want to set recalls because you're going to take away all the cabinet's detection. Come on. Field input termination assembly replacement. Again, you're taking away all the detection, so you might go to flash, or you might either want to be in flash or at least set recalls while you're taking this panel out. You don't have to do it live. This is all. There is one high voltage connector, but it's a little Molex connector, so it's protected. Output assembly. This one was this replacement was so long I had 2 parts. Again, Phillips head screwdriver, precision flathead screwdriver, and a 5/16 wrench because there's a little ground lug you have to loosen. So these pages take you through the steps to replace all of the assemblies inside of an ATC cabinet, like the Eric's Guide to ATC. Field output termination assembly replacement, which, you know, we'll be doing this when you guys get your fused photos. We just follow through, and again, Phillips head screwdriver, flathead screwdriver, wire cutters for zip ties. So we don't need a blowtorch here. That would be overkill. ATC cabinet service assembly replacement. So this was written for the vertical style service assembly, but the horizontal, kind of obvious too. Rack screws, wires. So the modularity of the ATC cabinet makes it super easy to service. Now, sending in the logs, and we are a little behind time, so I'm going to skip the EDI live session. Plus, I don't want to crash my laptop again if I turn my VPN back on. So this is what I mean by sending in the logs from EDI's perspective. Connect to ECCOM, download the logs. There's 6 log files. There's configuration log, monitor reset log, which shows when the monitor was either reset by itself or somebody actually pushed the button. AC line event logs, obviously monitoring the utility voltage. Previous fail logs, the last 30 events. The chronological event log, which is a summary of all of the other logs in chronological order. And then the signal sequence log, the last 30 seconds of operation. This is what we use to troubleshoot issues in Farragut in December. The last 30 seconds of operation prior to the fault, so we can see if there's any erratic voltage or anything on channels. Very, very useful. So these are the 3, 4, 5, 6 logs. You save them all individually. You zip them up. You email them to me. You email them to Don. We are blind without these logs. So when you say it's in Flash, we're like, okay, yeah, it is. Here's some things to try, but we really need the logs. Besides, I'm on an airplane right now, so can you email those to me? This is extremely helpful. ECCOM is a free software available on EDI's website, or well, we'll send it to you. I mean, hasn't been updated in years, and it is extremely useful. Also, this software is universal. Any Ethernet monitor, or even the newer serial monitors that EDI makes, this software is compatible with that. ATC, NEMA, Caltrans, doesn't matter. So collect the logs, save them, zip them up, send them to us. Now, I was going to do a live walkthrough, but I've been running my mouth a little bit longer. So let's, this is the end of ATC cabinets for this morning's session. So I want to pass the torch back over to Ayrton, open it up for questions, and take a quick break. I need to, I need to stop talking.
So the only thing that came in about 45 to an hour ago was a comment. ATC cabinet in Pennsylvania, ground rod was reading 64 ohms. I'm hearing ATC cabinets are very sensitive to grounds. We were getting circuit breaker faults consistently. No breakers fuses were blown. We installed a new ground rod, and knock on wood, it has been running for a week.
Hell yeah. I might know this cabinet. So let's zoom out real quick. It's not just ATC cabinets that are sensitive. Back in the good old days of the 90s, when we started adopting NEMA TS2, we had the same problem. Serialized cabinets require constant communication between the controller and the monitor and other devices inside the cabinets. The controller sends out a command frame, and there is a time there's a timeout that the monitor or whomever else needs to respond to in that time frame. Otherwise, that is that there's a fault there. 3 faults in a row will go to flash. All right. So what's likely happening? Well, maybe that circuit breaker wasn't tripping, but something was putting trash on the serial line, and the controller, the monitor, serial bus 1 and serial bus 3 essentially had noise on that line because of a inferior ground. This used to kill SDLC ports on controllers, or this does kill SDLC ports on controllers. It burns up SI bus interface units and serial interface units. It burns up monitors. It burns up Polara ICCU2 units. It burns up video detection units. If there's electrical noise where there's not supposed to be, it could eat an RS-485 transceiver for breakfast. That's what it sounds like it's happening here. I like to explore a little bit on the circuit breaker trip, because that should all be AC signals. But then again, if it's a GFCI kind of circuit, again, if there's noise where there shouldn't be noise, then it's going to make the circuit breaker unhappy.
All right. Well, I was not going to ask you that, but since there are some people pressing here, questions for Eric. Somebody has made a comment that you like Taylor Swift. Is this true?
Yes.
All right. Now on the serious
It's
part.
me. Hi.
So from Ted.
Was that Bob?
Well, this one is from Brenton, but Ted Bacon is the one that started the thread here.
Oh.
Is it possible for a switchback to go bad on one channel and that output
Fuse? Oh, I shouldn't answer.
And that output voltage be less than the other channel?
Yes. Yeah, it's an individual driver. I'm gonna repeat because you're not on mic, but yeah. It's an individual driver, and once something fails, I feel like channeling a little Scott Evans here, but like all bets are off on how it's going to actually fail. I mean, we've seen switchbacks fuse open, we've seen them fuse closed. I had a complaint with GDOT actually. They were driving 8 blankout signs on one high density switchback, and it worked for a while, and then the output would fuse closed, but they weren't monitoring it, so they just called and said, hey, the blankouts are always on, and then we change the switchback and they go off for 30 days, and then they come back on. and it's like, oh yeah, the switch pack is being it's giving up. Yeah.
All right, just one more, and then we can go on a break here.
Okay.
Eric, I believe it's Hayduk, that mentioned earlier the previous question, and let me just get this to the right
Better be
place.
Taylor Swift.
I have the logs from the circuit breaker trips, if you'd like to see them. We
Oh,
are
yeah.
scratching our head. So yeah, just
Yeah.
send it to Eric. And in the meantime, there was another one that came. When programming a flashing yellow arrow and using the yellow on the same channel as a concurrent pad on a ATC test cabinet, I'm getting a multi-indication error where the pad is recalling. Is necessary to separate onto different channels?
Are you using virtual channel? Yeah, actually, there's a lot to unpack there, and it's going to be hard to do this through translator.
So we can respond to this later on. It doesn't.
Yeah,
have to be
yeah.
here.
Maybe is the answer. So let me see if I unpack this right. You're trying to use the yellow you're trying to use the yellow flashing as a flashing yellow arrow output. So that's the overlap green output, and we're getting a multiple indication. You'd have to double check your FYA configuration, and you'd also want to make sure you don't have multiple input turned on that PED channel. You shouldn't have to break it out. Now, that's kind of a mode G operation. Yeah, there is more to unpack there, but yeah, let's take that offline. That's a good one.
And question about is an M60 compatible with this cabinet? Is the new Unix blade compatible?
Speaking from experience, yes, the new Unix blade is compatible, and I want to make this offer right now. I will happily do an ATC cabinet training with a Unix blade. It's kind of an old friend of mine. Long story. M60s are compatible with the ATCs, provided they have the ATC board, and that goes into slot 2. Jesus, I hope I'm right. No, I'm sorry. It's a 2072B module, and they also have a 2C plus module that goes into slot 1 because the M60 doesn't natively have the C12S port. So that slot provides the C12S port that's needed for ATC cabinet communication. My advice would be to buy a 2072B plus module because 2C module. My advice is to contact Unix also. But I talked to Yuri, but the 2C module has the C12S 25-pin port for the ATC cabinet, but then it's got the 15-pin DC, the DC 15-pin port for TS2 operation. So you don't have to try to bend the will of the M60 to try to get TS2 back out of it. That would be my advice if that's available.
All right, thank you. So I added my email here if you have questions, so you can just direct them to me and I'll pass them along to Eric. And I also put the link for the presentation if somebody didn't get it yet.
Yeah,
all right?
and all of our email addresses, mine, Don's, James Roberts from RTC, CTC, and Ben Johnson from TCS, all of our emails are on the final slide of this presentation.
All right, that works too.
All right,
we're good.
Okay, cool. 15-minute break, 10:23. So let's start up. Let's round up. Let's start up at 10:40. Next, we're going to talk about cybersecurity and cabinet stuff, and then we're going to go into Omni, and that's So all right, quick break.
Thank
Smoke
you.
if you got them. Right. All right. 10:40, or 10:41 now, Eastern Standard Time. Let's get started again. So I divided this session into two parts: ATC cabinets and everything else. Well, congratulations, we're now on everything else. I will continue to dive back into ATC a little bit as I go into this this next segment, because it is cabinet specific or cabinet relevant. I'm going back to my roots a little bit and talk about cybersecurity. It's just something that's not going away. And actually, in the 6 years since I've been active, or since I've been 100% in intelligent transportation and out of information technology, it's only gotten worse. And it's only gotten stricter. So I want to talk about cybersecurity from two aspects here: cabinets and controllers. First, with controllers. Before lunch, I was talking about how these traffic controllers today are tiny Linux-based PC or computers, and you don't want to plug your smartphone into them because they'll talk to each other and all that other stuff. Being the fact that Linux is their operating system, now it brings into reality that that Linux operating system is running on a kernel that needs to be secured and needs to be patched from time to time. So, you know, it's part of cybersecurity is part of our world, part of our industry now. We have no choice in the matter. It's just, yeah, part of it. So at Swarco McCain, every time that we interface, or every time we our embedded hardware team does anything to the Linux kernel or changes the ATC engine board and such, they always are factoring in a cybersecurity concern and element. So earlier I talked about the ATC 5301 standard. The ATC 5301 standard is relevant to the cabinet. It's the functional standard. It's how the cabinet's built. Trust me, I'm not going to show you that diagram again, the functional diagram. But now I'm going to change gears, and I'm going to talk about ATC 5201 standard. This is the controller hardware standard for the ATC controller, Advanced Transportation Controller. This defines how the controller is built, what ports are on the front. It provides guidance on the Linux operating system and functions and application operations, even down to, hey, this is how you install the application on the engine board. It also defines the engine board, and I forgot a slide. Whoops. Yeah. All right. Well, I'm sorry. It does. No, standardizes ATC engine board. The ATC engine board is it hosts the central processing unit, the real-time clock, the Ethernet interfaces, the USB ports, memory, that's RAM and non-volatile RAM, flash memory, and all of the serial I/O. So asynchronous and synchronous ports for cabinet communication and communication with other devices. So the engine boards were intended to operate in all North America, are intended to operate in all North American traffic controllers. And the pipe dream way back in 2012 was we should be able to take the engine board off of brand X controller and put it on brand Y controller, and or take the engine board out of brand Y and put it in brand Z controller. In reality, that wasn't the case. Now in the Caltrans world, they enjoy this functionality because you can swap the CPU modules, because the controllers that comply with the Caltrans state spec are allowed to run any software. And we usually achieve that just by putting in manufacturer X's CPU module into manufacturer Y's controller. And the CPU module includes the engine board made by that same manufacturer. In the NEMA world, forget about it. We're not there yet. I'm actually giving a couple presentations on interoperability later this year out west. One in ITS Heartland, and the other one in Western ITE in Long Beach, California. But the intention was interoperability. Not quite there yet. However, what we also did when we created the engine board was we created a micro PC, Linux operating system. We created all of these things, standardized processors and such. And we went from a proprietary, manufacturer-specific processing interface over to using industry standard off-the-shelf operating systems and such. Made us immediately have to go into cybersecurity. But before we go any further, I want to do some terminology, especially McCain terminology. So Swarco McCain has three engine board series. Engine board 2, the original engine board, 2011. Don't ask why there's no engine board 1, or let's not talk about engine board 1 right now. But engine board 1 and engine board 2 were almost interchangeable. Engine board 1, it was kind of like the ugly prototype. Engine board 3 came out in 2016, second generation. And then engine board 4 is our current flagship. We have 3 different engine boards. Yay. The history and specs, I'm not going to read all of this stuff. This is take-home reference material. The key takeaway here is that engine board 4, well, first of all, the key takeaway is that they all have the same CPU, but engine board 4 has 512 megs of flash memory. So it can store the application, or it can store multiple versions of the application, Omni, D4, whatever. There's plenty of storage for that, and there's also plenty of storage for 2 Linux images. So that's good for upgrading. Identifying the engine board, McCain engine board. The easiest way to tell is look at the supercap, the little blue capacitor in the corner. You can see the arrow pointing to it. Engine board 4s have a smaller supercapacitor than engine board 3s. Engine board 2s don't even have one. We do have part numbers, but the supercap's easy to tell. So here's engine board 2, nothing, no supercap. And then engine board 3 has a larger supercap than engine board 4. So when we came out with engine board 4, we redesigned the hardware and software with cybersecurity in mind. Again, we work hard enough to get on qualified product lists and win jobs and and meet specs when they're asking, or when the engineer and the consultants, when all the other requirements are, you must have the support for 32 channels and 8 flashing yellow arrows and 250 coordination patterns, blah blah blah. The operation of the actual system, the operation of the cabinet. It's now, but we're seeing more and more where our controllers have to meet cybersecurity specifications that previously nobody cared about. Oh, you must meet transport layer security, or TLS 1.3. We will not allow TLS 1.0 devices to be connected to our network. Okay, man, we need to make sure we do that. SNMP version 3, simple network management protocol. We need to, we need to push to that, because hey, everybody's controllers communicate with SNMP version 1 right now, and guess what? That's clear text. It's unsecured, but that's just our industry. And now I'm looking at you, Preston. I can talk IT now. So we designed engine board 3 to be future-proof for cybersecurity enhancements, in addition to regular operation of working in a traffic controller. So we also designed it to support third-party applications, so we can actually load the other guy's software on our controller unit, and then make it easier for upgrading and such. Engine board 4 does not get the dreaded serial cable reload like our previous engine boards do. No, it's a USB thumb drive. Cybersecurity feature number 1, and most importantly, root password management. How many people have ever turned on a GridSmart unit for the first time? And how many times have you been annoyed that it's making you change the password before you do anything else? Huh? Yeah, every time. So, and I say GridSmart because as far as I know, they were the first to have done this. Conforming with California Select Bill, House Bill 327, saying that manufacturers of connected devices, IP addressable, must provide reasonable security and not ship a device without a default root password or backdoor password. We've all seen plenty of movies where, you know, the big evil corporation has secret backdoor access to all of the to the devices, and they just own us overnight. That's what that. Shut up. Not like Apple. You must be an Android user, Frank. He's got an iPhone, so you know, Tim Cook's listening in. That's why I was a BlackBerry user for so many years. So this law, the intent of this law, when I read it, says manufacturers can't have backdoor access. The end user gets to secure the device and whatnot. In reality, it's a little bit harder, especially in our industry, because if Sevierville buys a controller from me, from Swarco McCain, they don't touch it first. It goes to, you know, through to the channel partner, and it goes to the contractor, who then goes and installs it. So they're not the first person to turn it on. So we're working on the implementation side of this. But first and foremost, stressing this point, we don't have a backdoor to this controller and an unrestricted backdoor access. And root passwords do have to be at least 5 characters long. Also, stressing this for Swarco McCain controller users, when you do get these engine board 4s and you set a root password or a root password set, doesn't matter if it's whoever sets it, it has to be recorded, has to be retained. We can reset that password administratively through like an RMA or you know, bench style work, but it's not easy to do. So it's your job, according to California, it's your job, and other agencies are doing this, and the FHWA, and there's a bunch of initiatives on this effort. But it's your job to keep your root passwords and maintain your root passwords. I've already had to reset passwords on a dozen controllers in 2025 alone because they're like, oh, I forgot what I put in there. You know, okay, annoying, slightly annoying. But change is bad until it's good. I know that's Scott Evans quote. Okay, so cybersecurity improvements. Number 1, root password set by the end user. Number 2, that root account no longer has the ability to remote into the controller via SSH protocol. So we've limited that. Now, there's a hack and workaround and blah, 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 but you can't just connect to the controller over the line over Ethernet and SSH and have root account access. That's denied by default. We've upgraded our SHA encryption, or TLS 1.3. We are only using secure file transfer protocols, no more FTP, no more telnet. You know, we're only using secure protocols. Again, for those of us in the room who care about the function of the traffic signal, this is secondary. For those of us in the room who lay awake at night wondering what device is going to get owned in the network and then create a broadcast storm or malware attack or anything, this is for you. Certificate management and onboard denial of service protection. Onboard denial of service protection. If you hammer on the controller, there's mechanisms to prevent that. Could you overdo it? Probably, but you know, we're doing our due diligence to secure this device, and not just have set the root password to be root and then never tell you. Third-party support. In the name of interoperability, we are starting to allow, or we're working with our competitors to load their software onto our engine board. Now, Fourth Dimension D4, we've been partners with them for a very long time. City of Nashville is looking at them, and of course, our friends at VDOT and San Jose, California, and many other agencies run this software on our hardware, no problem. We have a great relationship with D4, but the other vendors, hey, it's time we open up the party here. We're getting away from proprietary I/O with ATC cabinets. We're all just sending the same frames. Let's just share hardware. You know, so if you like Swarco McCain's controller, but you like Unix traffic software, why not? Let's party. So we're working on that. That's a huge effort. We can only do that with engine board 4, though. The unlocks that we've done in the hardware. Linux upgrades, Frank. This is cool. We don't need serial cables. Gary, this is cool. We don't need serial cables. Plug in a USB, turn it on, it'll load the Linux image. That's it. You know, why it takes 7 minutes still, but you don't need all the cables. You don't need the laptop. You don't need all the other crap that we used to pile on in order to do this. We have enough memory to store 2 images. So there's even a way that it's a real backdoor nerdy way, but you can roll back to the previous image just for a sanity check for bench work. So it's very cool. Maintenance mode. The maintenance mode allows for accessing the controller type configuration, because also, spoiler alert, our new engine board works in all of our controllers, all of our ATC controllers we've been building back to 2011. So that's going to be important when I start talking about the limitations of Omni on the oldest of hardware. User account management for setting up that backdoor account. You know, the city of Sevierville, the city of Pigeon Forge, or whoever's backdoor account. You can go in and key that information in. And of course, enable and disable services such as SSH for remote access or secure file transfer protocol. Accessing maintenance mode requires entering the root password that you specified when you turned it on ages ago. The other thing you can do is run the engine board diagnostics and acceptance test. I mentioned D4 earlier, so I'm kind of thinking, kind of zoomed out a little bit and thinking regionally. On our current controllers running engine board 2 and engine board 3, when you install the fourth dimension D4 software, the diagnostics or the DAT utility that we can access from our McCain Omni software is gone. It's not deleted, but it's rendered unavailable. So in order to get to the DAT, you have to uninstall D4, which is bench time for the technicians at VDOT. Engine board 4, the DAT's built in. You just turn it on, you push a key, it loads this menu, and you can go to the DAT. So you don't have to manipulate the software on the controller to find out if your connector box is any good. That's what the DAT would be used for, is testing ports, testing connector boxes, testing real-time clock and everything. So enabling services, all of the services on the engine board are on the managed services list. So you can go in there, turn them all on administratively. Now you only do this once, but this is something that you can do from the controller front panel before you set the intersection, before you go live at the intersection. And D4 specifically, I'm going to installing D4 on brand new engine boards. We have a fast track for that. I've worked with the team over at D4, Eric Nelson and such. So so Swarco McCain with our partnership with D4, we have absolutely made it easy to install D4 on the EV4. I feel like there's more to that slide deck, but I can't. I'm drawing a blank. Okay, so that's what we're doing to secure the controller. We're locking it down, limiting remote access, making sure that communication is going to be encrypted, you know, as much as possible. As new cybersecurity concerns come out, we can easily just reflash the engine board, update Linux, blah, 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 like Windows updates, right? Now let's talk about securing the cabinet. Holding the wrong thing in my hand. This is what I want to be holding. Yeah, number 2s. So give a shout out to my dear friend, Brian Wagner, not the one at McCain, but the one here in Sevierville. I reached out to him and I said, I need a quote. So he gave me a quote. I have argued, even with our own development team, I've stood by what Brian says in this quote right here. And I hate reading slides, but I'm going to say this out loud. All right. Cybersecurity isn't just about firewalls and protocols. Physical access is the first line of defense, especially with critical infrastructure. Compromised panel or cabinet, unattended workstation, or an unauthorized user can bypass even the most advanced cybersecurity solution. Controlling who has access to the physical environment is a critical part of cybersecurity. It's thing one. You know, Preston, why did we lock the server room up at the police department? So nobody has access to it, right? So we install fiber optics, cellular communication, all this great stuff in these traffic cabinets. Like I said earlier today, VDOT was one of the they made the decision to do this years ago. They limited access to the IT side, the IT infrastructure side. So what Brian's saying here is these number 2 keys aren't cutting it anymore, guys. All right. Let's secure the cabinet. Let's talk about how to secure the cabinet. So here's the problem statement. The number 2 Corbin lock is an industry standard. It's been around for years, all right? Available on eBay. I went on eBay last night. Traffic cabinet number 2 key. That's my key, my query. So that's a reasonable snip. There was thousands of these. I actually think that if I was evil, I would just buy these key blanks and just nick them up and then sell them for 20 bucks a piece. Because how would they know, right? I'd get a couple sales a month, you know. Agencies can choose to rekey the locks. Actually, on this key ring, I have 2 number 2s, and then I have. I know it's a number 2 as well, but it's a different key cut. It says 2 on it, but it's a different key cut. This is a custom key, a custom agency key. Okay, cool, clever. So now Progression Electric, you guys just can't whip your number 2 key out and go over to that agency and open that door until the guy at the office at the agency says, "Oh, you can borrow mine for a day." And then you go to Lowe's and then you get a copy cut because this is literally just etchings in metal, right? So it's only as good as the person who has it, and there's no audit trail. You still don't know if it was Eric who opened that cabinet door. You got the cabinet door alarm and transparency, but you don't know if it was Eric or Don, you know, or your central system. I shouldn't say transparency. So once you're inside the cabinet, all the devices are vulnerable. Imagine, I thought about this on my flight down, actually, as I was working on this slide in my head. How clever would it be? Preston's got a bunch of cell modems in the cabinets here in Sevierville. They're cradle points, IBR 600s, which isn't true. Preston actually has fiber in all of his cabinets. But let's say he has a cradle point IBR 600. So I go on eBay and I say, bad cradle point IBR 600. Buy it, 20 bucks, you know, or gov deals. Okay, cool. I go out there, take my number 2 key, take their cell modem, put mine in there. I've got their SIM card. What if they have, what if it's a private cell network where you turn it on and it's automatically VPN'd in? I've got their cell modem right there. I take that back to my evil layer and I do evil things connected to the city of Sevierville. You know, you want to keep these guys out of the damn cabinets. So somebody can steal the cell modem or just the SIM card. You wouldn't know. Hey, Progression Electric, go out there and find out where we're in comm fail. I went out there and I saw lights in the cell modem. Looks fine. Must be, I don't know, maybe it needs to be reflashed or whatever. It's got a bogus SIM card in it because they stole the SIM card. How easy is this? I mean, going back to talking about the ATC cabinet replacements, what do we need? A screwdriver and a smaller screwdriver. That's all we need to steal a cell modem. So like we got to start thinking about how these stupid little metal keys aren't cutting it. No pun intended. Or, of course, you can do the hacker thing and plug a malicious device into the network. You know, we've all seen those movies where the guy walks into the server room and he's all cool and he's just like quietly plugs a thumb drive into some random server, and the next thing you know, all the lights go out. I mean, like, okay, that's to an extreme, but not really. Because if I'm worried about your cell phone crashing the traffic controller because it plugged in and it started downloading your iCloud pictures, what do you think would happen if we had a actual script that had a, hey, run me when I'm mounted, and then do bad things to the controller kind of operation? This is crap we've been dealing with in the IT world for years. But guess what? Traffic's critical infrastructure too. So another shout out to a good friend and colleague of mine, Brent Trimmer, Riverside County, California, former Swarco McCainer, and now he manages traffic with the team in Riverside County, second largest county in California. All right. So earlier I was talking about like Maine, you drive the technician or send the technician halfway across the state, they have the wrong thing, and so they have to drive back and whatnot. Think about that from a cybersecurity perspective. Riverside County is the second largest county in California. California is pretty damn big. So some agencies are directly responsible for cabinets over a large area. Remote cabinets need to be secured. You got some nut job in the desert in California. He's like, you know what I'm going to do? I'm going to go in the cabinet and I'm going to hack in because I watch Saturday morning cartoons or whatever. So they break open the cabinet and then they have access to the cell modems. Again, the cell modem that I said you could just steal and replace it with a dummy. I mean, if I can think of it on an airplane, then why can't they? So Riverside County, compared to Maine, because obviously everything's better in Maine, but except parts of California, Riverside County is 1/5 the size of Maine, okay? Quarter number of intersections, Maine has 800, has 1 million more people. Just takes a few more nuts. I mean, you know, we're a little kooky up in Maine too, but still, they have to secure their critical infrastructure against 1 million more people in a smaller area than the state of Maine does. That's a challenge. Okay, so what I'm about to do is exit my comfort zone. I'm going to give a presentation of a product that I do not sell, okay? But I'm a manufacturer of cabinets, so I have to, so I want to stress that all of this stuff works in our cabinets, and I want to stress, I want to get the wheels turning in everybody's heads here on why we need this, why we need this as manufacturers, why we need it as contractors, why we need it as agencies, why Ayrton needs to stand on the rooftops as well and say, upgrade your keys. No, kidding about that. So this is a couple of weeks ago, I traveled with Corey from Alcia or Asa Abloy. I'm not sure actually what they go by because their shirts say both. Corey's a great guy, and he shared this with James Roberts. He shared this presentation with James Roberts, who shared it with me, and then I kind of workaized it a little bit, or i.e. putting it in my template, right? So I don't sell these products. I do support them, all right? In the room here, we have James Roberts from RTC Manufacturing / CTC, representing Asa Abloy or Alcia, and we have Ben Johnson with Transportation Control Systems. They represent Cyberlock. So I'm not leaning on one product or the other. But I want to talk about how cool electronic locks are. Nerd time. Okay, so Asa Abloy calls their product click keys with the Protect 2 or Protect 2 system. All right. It's a smart hybrid locking solution. So it's a key, it's a circuit, it's both. So Alcia, I left this in there so you guys can get a look at Corey. If you don't know Corey, he's the one on the right, and he threatened to beat me up if I screwed this up. So, and I think he could do it too. He's a little, I'm kind of scrawny. I mean, you know. And also that's the city of San Jose, which I go to San Jose about once a year for ATC cabinet training. So that was a neat little coincidence in this presentation that we're already partnered with Alcia through San Jose and through other agencies. So they are basically an access control company. Zooming in, and I actually trimmed the presentation down because I would just want to talk about traffic. Zooming in, traffic enclosure locks. Number one, these are a drop-in replacement. This is the same, look, exact lock dimensions as the number 2 Corbin that's on this bugger. Can you camera me, please? No, sorry. So here's the old Corbin from this 2015 cabinet. Here's the new Asa Abloy. Of course, it's going to be like that, but same exact drop-in replacement. Available in mechanical or the electronic click, and it's compatible with all North American traffic cabinets. And Cyberlock's the same way. That again, this is not a commercial for Alcia. It's what I want to convey is that this isn't a hard road to take. It costs money. You know, everything costs money. But guess what? IT spends thousands of dollars securing their server rooms. So that's their server room right there. Probably scared Preston a little bit when I said, yeah, somebody could just steal the cell modem and hijack the SIM card. They also have padlocks, which hell, if I had this solution back when I was doing water and sewer, I would go with, I would say, hey, we need to switch over to these padlocks, because I don't want people climbing to the top of the water tank with the brass water department key and opening the hatch and throwing God knows what in the water supply. So padlocks. This is polycarbonate boron, tritanium, dilithium crystal. You can't cut this with anything, according to James. He's not paying attention. So this is industry standard metallurgy as far as you can't cut it, or you should. Boron steel, yes. You don't like my polycarbonate, dilithium crystal, magnesium Iron Man suit armor? Oh. Yeah, you can submerge this padlock. So a lot of agencies both lock their cabinets with the internal lock and they padlock it. But even for agencies that want to just standardize on, I'm getting a little salesy here, forgive me. They want to standardize on one locking solution for multiple systems like your public utility, water and sewer, substations, and traffic. Hey, look, here's a padlock. It doesn't have to just fit on the traffic cabinet. So here's the minimum system overview. Key programmers, programming key itself administratively, the user key, this dude that you hand out to the peeps, they can't change this key, they use this key, and then your locking mechanisms, and then of course your central management system to maintain credentials and access periods, access accounts, access control, and most importantly, audit logs. Because again, Preston, if something happens in the police department server room, first thing you guys do is you log in and say, who's been in that room for the last 12 hours? Who swiped in? You know, you guys, Don, you and I have seen this many a time at an airport. Watch them close the door to the jet bridge after they empty the plane, and then they close the gate agent closes the door. They key in the number. They relock that door because what they're doing is they're generating audit events following standard operating procedure. And every time they open that door, they key back in, and then they close that door until they're ready to start boarding. It is utterly important that they secure that jet bridge. A traffic cabinet, kind of the same, just as important to me. Once it's connected to the network, bad people can do whatever they want if they break into that cabinet. I can't believe I just thought of the jet bridge thing. Yeah, that's a good analogy. Yeah. And another shout out to James Roberts, because he once chastised me for not doing this. There are integrated dust covers, just like in your number 2 Corbin locks. So we're keeping dust, moisture, everything out of the key cylinder itself, so we're not freezing. So there are several different types of keys with this particular product. We have conventional metal keys. We also have the smart keys. The smart keys, I'm going to move forward to those because those are cooler. Of course, lock tumbler, yeah, like you'd expect. Hybrid key has a code. The smart key actually powers the lock. CyberLock works the same way. The key is the power source. So there are no batteries inside of this lock. There's a supercapacitor or something along the lines that once you insert the key, you should be able. Oh, you got to put it in the right way. You gotta let it read real quick, and then after it reads, the lock is energized and can turn. Oh, it says red. Oh, okay. So James is telling me I'm using the wrong key. Yeah, so plug in, turn on, good to go. So if my key's access is expired, if I'm Progression Electric and the job is ended and I'm supposed to turn my keys in because I didn't win the service contract or whatever, then my keys won't work anymore, even if they worked 5 minutes ago, which they literally were. He showed me this over the break. So this is the way to control access to these cabinets. Can somebody still crowbar the cabinet? Absolutely. Can somebody still find a way into the cabinet if they want to? Yes. We are actually putting locks, we're putting large clasps around cabinets in certain areas like Washington State, because homeless people are breaking in and plugging in their cell phones and stealing the power. They don't care about the cabinet operator. They could give 2 craps about load switches and whatever. They need to charge their cell phones. So that's going to happen. However, the police department's going to get called and say, hey, there's a nut job with a crowbar beating on this cabinet, versus some dude in a yellow vest who just walks up gingerly, opens the cabinet door and does his thing. Oh, I'm wearing a yellow vest. I'm a consultant. I'm here to take pictures of the inside of the cabinet. Whatever. You don't know who it was. That's why we need this technology. I mean, go through the RFP, acquire the type of the name and feature, the name of the solution and the feature set that you want. But the metal keys aren't cutting it anymore in 2025. So the admin, of course, any system like this has to be easy to use. Actually, it doesn't work anymore. This is the proximity key fob, and we have proximity cards for access control. It's part of the industry. There's someone sitting there somewhere programming the ID of this proximity key fob or my proximity card and saying what doors I can open and when I can open them and everything like that. Somebody has to administer the system. Somebody programs this. You know, James set up access for that little key, or you had Corey do it or somebody just a few minutes ago. And then when that access expired, the key became invalid. The same would always go for our conventional access control systems. All we're doing is we're extending that access control to the field. So the system is easy to maintain. And again, I know with CyberLock as well, the key is the battery. So you gotta have, so they've designed these systems to where the keys just work. Batteries are fine. The keys are waterproof. So if you drop them in a puddle and everything, like they thought of everything. I wonder where my car keys are. Oh, they're in the car still. I mean, we've been using keyless entry in vehicles for years. We've been using fob-based operation in cars for years, where you know you keep your car key in your pocket and you never touch it, and yet your car knows when you're sitting in it. So, we're not. This is not a reinvention of the wheel. This is just, you know, ITS coming up to the surface that the rest of the world has been living on for the last 10 years. Of course, user credentials and access rights. Lock and cylinder, again, easy. No batteries, no wires, easy installation. I mean, literally 4 little screws takes this this number 2 lock off, and I put on the click lock. You know, here in Pigeon Forge in Gatlinburg, you have thousands of pedestrians. And if they find this on the side of the road, yes, you're not getting in that cabinet. But if this key breaks off in the lock, same problem. You're not getting in that cabinet. If this key is damaged, when I had I still have a car that uses a metal car key, DeLorean. So my key is 40. My original key is 40 years old. It's worn down to the nub. All right. I don't use it anymore. I had it I copied it before the teeth were too worn down, but now it's just like an old dog. I wouldn't dare use it. But if this key is damaged, then it's not open to that number 2. I remember Brian Wagner, City of Sevierville, telling me once upon a time, the first time he tried to open a cabinet door, he turned the key the wrong way and he broke the key off. How many people have ever had to fish a key out of a tumbler? Yeah, or replace the tumbler. So it's kind of the same idea. Now it's damned inconvenient that your key doesn't work, but also it's doing its job. I believe, James, correct me if I'm wrong here, the difference between the blue key and the black key is the black key is an admin's key, right? No, the black key is going to be. There's a red key? So the red key lets you into the matrix. Oh, I see. All right. All right. All right. So black key is a staff key. So this key will stop working only if the user is deleted or the user's killed. Okay, so the wall PD is where the staff comes and hits the key every day. Right. And I assume CyberLock is similar, Ben? Yeah, so because these keys aren't connected, they have to be told. They have to be they have to get a configuration update saying, "Hey, look, your key's good for another week because you're good to go." Yes. Mm-hmm. You'll be like, okay, you're good to go. So then he'll open his app, update his key, and then you'll have like 5 minutes or whatever the predetermined. Okay, so the blue key is app driven by a cell phone. So Wayne, if your key didn't work, then and if you had a blue key or whatever, then what you would do is fire up the app and make sure that the key's configuration is current. And then like
your other slide there, but the battery was to go there for some reason before you ran. It's just a little like lunch battery.
Yeah, it's a CR 2040. It's a CR 2042, right? Yeah. Oh, 2450N. Yeah. I mean, yeah, yeah. These are common watch batteries. You can go to the grocery store and buy these batteries. So again, this is a very simple solution. It is different and it costs money. I'm sure these systems scale out as far as the number of cabinets you have, the number of keys you have, all this. However, if it was $100,000, it's still cheaper than somebody plugging into Sevierville's FieldCom network and setting up ransomware that ate the traffic system and then jumped across the firewall or whatever. I mean, when I was here, when I was IT director, I had 2 ransomware incidents. They got me the first time. The second time I felt it happen, so I cut them off right when they got in. But the investment's worth the risk, because the risk is somebody owns the network. And if it's an adaptive system or a traffic responsive system like they run here in Sevierville, or even if it's just, hey, we own the traffic controllers, let's put them all in flash. Oh, that's going to be really inconvenient on a 4th of July weekend or whenever you wanted to do that. So physical access is critical to cybersecurity. That's a good question, though, Wayne. What happens when it doesn't work? So the system's scaled, built out. 3,500 authorized groups, 65,535 individual locks, and I'm assuming the same for keys themselves. So New York City has 13,000 intersections. If they wanted to cyber lock their cabinets, they could. 65,535. Our largest agency in the country is New York City, right? All right. And so we're good to go there as far as scalability. Actually, for an ATC cabinet, it could be, honestly, with a 350i 4-door cabinet, has 4 locks. So that's 65,535 divided by 4. Is the number of cabinets that this solution would support. However, I bet they could change that. They could just they could make that change. Yeah, make it be a 32-bit, and then that's what, 4 million, 4 billion. Yes, I knew it began with a 4. Okay, getting back on track. A couple of use cases. San Jose, California. Oh, look, that's a McCain cabinet. So a quote from Darren. I work with Darren. I enjoy visiting San Jose and Silicon Valley. Very easy installation, drop-in replacement. So literally, all of the setup is on the back end. CyberLock is the same way, I'm sure. It takes longer to program the keys and set up the database and everything than it would be to actually install the physical lock inside the cabinet. Now, it take you a while to go to 1,400 cabinets. That's another story. But the actual work inside the cabinet is just a matter of what he's doing there. 4 little screws, and take your number 2 off and put your the new lock on. Heck yeah, absolutely. Check that flasher alarm, make sure it's not active. Now, the other thing that can be done is new construction, new cabinets, ordered from the manufacturer. Swarco McCain, like I showed you the picture of West Des Moines, where they have all the bits and pieces that we don't sell, the Clary unit, the GridSmart processor, all that. We'll install these locks for you. During COVID, actually, there was a shortage of Corbin lock cylinders. So we had cabinets piling up at the office that didn't have locks because we couldn't get Corbin locks, because we install by default the Corbin lock unless it's otherwise specified. So this is where working with the cabinet manufacturer, working with the channel partners to get cabinets outfitted with the exact hardware, like we do in Texas, Grand Prairie, Texas. They have a beautiful cabinet. We're going to see it in a minute in the Omni section. Raul Perez, he a great guy. I work with him. I just saw him not long ago. They ordered the cabinets from Swarco McCain with these Alcia locks inside of them already good to go. So they don't have to do anything when they get these new ATC cabinets and they set them on the pad. Benefits of being a hardware company. I'm going to pause there real quick, Ayrton, if you want to poll the audience, see if anybody has any questions or thoughts. And here, same with you guys. Okay, cool.
One comment I would say, crash reconstruction, including traffic signal, right? Have information about who got into that cabinet. Start kind of finding out what's going on, who changed anything in there.
Yeah.
So that's another thing that a little bit on the side, but again, you need to protect your cabinet.
Absolutely. You bring up a really good point there because, yeah, bringing up. Let me unpack that real quick because when there's a crash, we go out, we get the monitor logs, we get the controller logs, we get all relevant data. Yeah, supposed to. We're also supposed to be calibrating the monitors once a year too, but so we get all of these. We're supposed to get all these things, but there isn't a sign-in sheet for the cabinet. So 100%. So interesting. We're almost at a lunch stopping point. We're 30 minutes to go. Any other questions on locks? I'm gonna go all the way. I'm gonna go all the way up to noon, and then we'll wrap Zoom, and then we'll do Omni. We'll continue on an Omni after lunch. But I do want to talk about Omni EX first, and I want to cover the most recent talking points in the last 30 minutes of this Zoom session, and give anyone who'd like to know more about what we're up to with Omni, give them the chance to chime in with questions before we wrap. And then we'll go to lunch. All right, so this last presentation, also this is a take-home version, so there's that too. But this last presentation, before I get to the wrap-up stage, is what I call Omni EX 2025. And this is the quote on this slide, which you guys can't see because of the little Zoom banner down there. I'll read it to you. This quote is actually from the former IT director here in Sevierville. This was his quote, Jim DeAnda. This is one of his famous lines. He had a lot of phrases, almost, or he has. He's still with us, thank goodness. He has a lot of catchy phrases. So when I wrote this presentation, I thought of him and used his quote. After years of hard work, we're an overnight success. Because we busted our butts with the Omni EX application since its inception in 2011, and we went through some rough times with COVID, developers, obviously collaboration, all of the things. But we are on a path now that we've been meaning to be on for the last few years. The company has invested more in this application in the past 18 months than it did in the previous 5 years. So after years of hard work, we're an overnight success, and it's getting better. So the Omni EX application, these are backwards. Yeah, well, backwards for what I want to do. We're gonna be time travelers. We're gonna go forward because this is the Omni out of box presentation. I don't want to talk about that. I want to talk about this. We'll go to the out of box presentation for the in-person peeps after the class. These are the features in the application. Along the lines of after years of hard work, we're an overnight success. Oh, shoot. It didn't change. Show me the slide. Let's do this again. All right, fine. Be a jerk. Blah, 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 blah. You guys get to see all this stuff later. There we go. What's new in the application? Thank you for pointing that out before I went totally off the rails. This is what we've been working on. Thing one, another Jim DeAnda saying, ped overlap rework. If you've ever used Omni EX, our pedestrian overlaps were rigid. They were designed around the NTC IP 1202 standard. The only place I ever used a ped overlap successful was Gatlinburg. Light number 3 at Old Reds, there's a ped overlap there because we figured out how to make it work. We redesigned it so it's less rigid now. It's more functional. And that allows us to do things like connecting a mid-block crossing into an actual signal cabinet versus having to do a separate cabinet for a mid-block crossing, because now we can treat that as a pet overlap that runs anytime. That was a limitation in our old versions of Omni. Really kind of lame, but hey, after years of hard work, right? The installation process, we've done it again. We've changed the installation process. This one's easier though. I'll get into that. New web user interface. A couple of years ago, our name changed officially, and our name and branding changed from McCain to Swarco. So we just rebranded the web server and added some new features for remote access capability. And of course, bug fixes. Improved pedestrian overlaps. Now we can have any phase be an included phase. And then the pedestrian overlap can be prevented from coming on by programming excluded phases. So this allows us to have a pedestrian operation come up whenever we need it to, regardless of where we are in the ring sequence. We can have the detectors call. We can have multiple phases, multiple PED phases call this PED overlap. And most importantly, we have independent timers now for the PED overlaps, whereas before they used to inherit the time from the main street. So this is very cool for from the included phase PED timings. So this is very cool for independent PED operations or complex PED operations. I'd actually kind of like to use this in Pigeon Forge, where you have some of those goofy PED crossings. We'll break those out as overlaps so we can turn them on and make them be a little bit more efficient. Application installation. We have a new package file. It's a single firmware package file. Again, we tried this a couple years ago. It's the SMFW file. So this is the Omni application. We also have a new secure environment. Is that on here? Yes, we have a secure environment, which is also its own file. So the secure environment was a prerequisite for us to take on the interoperability, because we have to be able to install Omni on our competitors' engine boards now. So we have to create this environment to kind of level the playing field. Unsecured operations, going back to cybersecurity, such as standard USB startup scripts, are no longer allowed after the environment's deployed. This fills a gap in the ATC standard that says anybody can walk up to a controller, plug in a drive, and if it has a file that says startup, the controller will execute whatever that script tells it to do. That's a wonky requirement. And of course, we can uninstall this secure environment, uninstall Omni from the front panel. No more serial cables. Evolution of the installation process. Let me just say that it takes 3 to 4 minutes to install and upgrade now. So why do we have another installation method? Because we love torment and torture. Actually solves the nuance. If we have a file named startup, and here's a dummy script right here of what a startup file could do. In this dummy script, I wrote, first it says it puts a message on the screen, and then it deletes all of the Omni application, or deletes whatever I tell it to delete on the engine board. And then it tells you that everything's been deleted, and then it starts beeping, laughing at you, okay? That's just me on a Saturday playing around writing this slide. However, this could be malicious, and this is allowed by the standard. So we can conform to that. We can still support startup scripts as long as we sign them, and and that means we can also work with the manufacturers as long as we sign, as long as we all agree and we have these startup scripts and they're signed and they're approved and everything. Then they can work on the controllers. This isn't us being proprietary. This is us being safe. I hand Frank a script and say, or Gary, and say, hey, plug these into all your controllers. He. And then, or Progression gets this, and they go around and plug them into all the controllers. And then the next thing you know, the controllers have something bad written on them. This is essential. I remember back in the IT days in the 90s. That's how old I am, even though I shouldn't be. Remember a 3.5-inch floppy disk had a little slide lock on it that made it be write protect, because a computer virus back in those days, that's how it jumped from computer to computer, via floppy disk. So if you're a technician like I was, working at a computer repair shop, all of our floppies, we actually broke that lock off or broke that slide off, so they were write protected. So our utility disks were read only. So we would never be able to spread viruses because we did that accidentally once or twice. This behavior by the standard allows us to do that. Hey man, infect the USB and then go down the line. Oh, let's go pick on the city of Pigeon Forge or the city of whatever. We decided to do this. Standard didn't make us do this, but we decided to do this for a reason. So this also levels the playing field. The environment levels the playing field for interoperability, and it sets us up for over-the-air updates. The other thing that we do, and why I've got all the Zoomers on the call here still, is we have a user manual with each release. Shocking. Now, in the past, yeah, I know, Chris is laughing at me now. In the past, due to COVID, due to logistics, due to whatever, we've struggled to release a user manual and release notes with every single release of Omni. Guess what? 2023, we hired a rather savvy tech writer who sends us weird memes like Dinner Cat. So that's my shout out to him. And we have a team of people, myself included, who go through and update release notes and work on the user manuals and have all of this done, streamlined through his new processes before launch day. So when we're ready with a new version of Omni, we're ready with a new version of the user manual. So you guys can figure out how, to program the new features and all that stuff. As long as I'm on that team, Omni will always have an up-to-date user manual. Web user interface. So we changed the colorization of the web user interface, but also most importantly, I love this feature. Don, you use this all the time too. In our eCabinet display, which previously just had all of the controller I/O, so you could see the outputs and you could turn on detectors and stuff, but we forgot to put the front panel as a widget. So we added the front panel as a widget in eCabinet. So now you can turn on detectors by clicking the little buttons and then watch the controller in real time or make some tweaks and changes without having to go to another window. Super, super useful. Oops, I forgot to trim off. Yeah, I recycled this slide from a previous seminar. Undocumented feature fixes, of course. Undocumented features are a term that our Canadian distributors uses. That's what he calls our bugs. We're in software development. We're going to have bugs. I mean, I hate to say, in a perfect world we wouldn't, but we're in software development. The installation process, super, super easy. Again, I'm saying this while we still have time. How much time do we have? 11:38, good. 4 steps: prep the engine boards, load the environment, load Omni, post-install, reload the database. Always back up the database first. Prepping the engine boards is the most important step here. Engine board 3, so that's our EX2, our Flexes, our 2071Cs. Everybody in this room has engine board 3. Some of you have engine board 2 as well, your EXs, Frank, but we'll talk about that later. You upgrade to the latest Linux image number 356. Anything older than 356, you have to update. You enable SSH. We have a USB script to do that. You do that before we load the environment because it can't do it afterwards. And then you back up the database. Engine board 4, which nobody in this room has engine board 4 yet. We have to update. Minimum image requirement is image number 132. So on screen B5, kernel version 5.10.105, image 132. So so we have to update to that. That's just a USB load. Load image 132, and then it's a new Linux image, so it's going to ask for a root password. So you do all the couple little setup things, and then you're good to go with that. Now, our old controllers that run engine board 2, they have to be updated. You have to buy a new engine board. Wayne, you're good to go with this because all you have is EB3. Gary, you're good to go with this because all you have is EB3. Frank, you've got a couple EX controllers that, even the one I bought originally from Doug Williams back in 2015, that one has to be upgraded. That's a rather small hardware purchase. Take the old engine board out, put the new one in, and then it's updated. The reason we don't support engine board 2 is the application physically won't fit in the flash memory. EB2 has 3.8 megs of storage on the partition where the application installs. Omni needs 12. Sorry. I mean, yeah, we run it. I mean, well, we have to have enough for two. Because over the air updates, we have to have enough space for two Omnis in order for that mechanism to work. EB2, all right, a long farewell. You know, I mean, there's nothing we can do about it. Preparing the USB drive, we have a deployment package, but we also just help with that. Install the environment, simple. Your USB drive's ready. It's got the environment, it's got Omni on it. Plug it in, turn the controller. It installs the environment. It tells you to turn off. It tells you to pull the USB, but don't pull the USB. Just leave it on there. Leave it in. Turn it off. Turn it back on. It starts installing Omni. It'll ask you to press enter just to confirm what version you're installing. Press enter. It installs. It says turn off and pull the USB. Turn off, pull the USB. You got Omni. Reload the database. Now, we're reinstalling Omni because of over-the-air updates. Finally, after years of hard work, we're an overnight success. We can now inject a file to the controller via the web user interface, or we can install via USB or doing a live update. Omni 3.9, we didn't perfect over the air. So we still require that the intersection be placed into local flash before you do it over the air update, because it will go to flash for a moment. So control the flash event versus just saying, all right, go to flash for a second. Now, what happens is you send the file to the controller via USB or web server. Then the file is loaded. The Omni returns a confirmation saying, okay, I'm loaded. I'm going to go to red rest. So whatever it's doing, it goes to a red rest state. And then it switches application. It's during that application switch that we go to flash for a brief moment because the cabinet holdup goes away. So the ATC cabinet serial bus 1 communication stops working for just a brief moment. CVM, our voltage monitor, fault monitor, and TS2 and TS1 stops working. Caltrans watchdog pulses stop working for just a brief moment, and then it recovers. Is there a question, Harrison?
No, just a question.
What's the comment?
Friend Brent, anyone ever asked Eric what the acronym for Omni?
I can't say that out loud. It's Brent's actual, screw it. Brent Trimmer right here, folks. Operational malfunction, notify ITSL.
We're not joking.
We're not joking. Yes, you guys missed me that 6 months I was gone. That's good, Brent. Thanks. Now, when you do an over-the-air update, databases are preserved. They're backed up. So, I mean, I always suggest back up the database. If you feel, when in doubt, back the database up. But the people are calling me saying, "Oh my God, why is the database still there? I updated Omni and it's still there." I'm like, yep, because after years of hard work, we're an overnight success. Uninstalling factory defaulting. Go to menu B0, confirm factory reset. You press yes. It doesn't wipe Linux. It removes Omni. It removes the secure environment. And the next time you reboot the controller, it goes to diagnostics. Or EB4 might go to blank screen. Can't remember what EB4 does. All right. This next part is use cases. Putting the best of Omni EX into action. This is the part where I wanted to rush to get to this part. And I want to cover this in the next 5 minutes because I got some really cool crap in this section. So I've actually caught lightning in a bottle once. I was playing with a Tesla coil and a beer and figure that out. It's always been the goal to catch lightning in a bottle. I think we got it. Now, keeping it there is going to be a real bitch, but oh, shoot. Forgot this. Oh, whatever. And let's start talking about innovations. Let's start breaking this out. Yeah, we can turn lights on and off, but let's make these controllers really do something cool. So I'm going to go through 4 quick use cases. Red light protect, been around for 3 years. We put it in Omni 3.4. Split ring operation with ped overlap. We now can do that with our unlocked ped overlaps. Literally a mid-block signal down the road that runs independently, but is still wired to the original cabinet. Ped safety, NTCIP version 3, ped support. Ayrton, you and I were talking about this on the break. And then red light ped protect. This is a mod of red light protect. We're crashing the red light protect party. Why did I say that? Must be a Taylor Swift reference. With a mod that activates red light protect prior to, yes, it is actually, to a ped service. Maine DOT and several others gave me this idea. And there's only one intersection that's actually using this feature, and that's in Maine currently. However, Joseph's going to sign off and let me do it at his school zone soon here in Sevierville. So first, red light protect. A red extension triggered by a specific detector when a vehicle is about to run the red light. Dilemma zone detection. All right. Vehicle enters this zone during a yellow or red interval. Omni says, oh, there's not going to be enough time remaining in the clearance intervals. I'm going to add a program value, 1, 2, 3, 4, 5 seconds to that red, to the red clearance, and then let that vehicle clear the intersection. Omni sees a detector which is programmed. It's an assumption detector. So Omni says, all right, if you program this red light protect detector, you're telling me that someone's about to run this red light. So if somebody runs that red light and that detector turns on, or runs the yellow or red, and that detector comes up, Omni does the math and says, uh-oh, they're running a red light. Adds red extension, locks the intersection in red. People say, what about coordination? What about coordination? What's worse? A vehicle turned on its side because they got T-boned, or going into transition for one cycle. Do the math. All red light protect events logged to the controller high res and the actual boring old controller log. So we have analytics we can bring back to central. Bingo, yes. Yep. And then it's detection agnostic. We need a detector we need a unique detector, but we can even use logic, which I'll talk about this in a minute, to set up dummy red light protect detectors, and maybe that are something else. So if somebody enters a regular old advanced loop, but you know it's a dilemma zone kind of detector, we can give it a second role as a red light protect detector. Next one, split ring with overlaps. I'm only going to go through 4 of these, and we'll open up for questions because we're running out of time. So this is what I'm talking about. Nobody. Oh, I meant to take that out too. That's not a Taylor Swift reference. I was just having fun. So this is Santa Barbara, California. This is a simple intersection. It's 2 phases. Phase 2, phase 4. This is a split ring operation down here. This guy is a ped mid block and then a vehicle through. So essentially, this would be a ped overlap, and this is a vehicle overlap. And the ped overlap only comes up with a push button. The cool thing is that I don't need a second cabinet down there. I can drive that lower intersection out of the controller, out of the main controller in the cabinet by treating that as a ped overlap output and a vehicle phase for the through. Now, a lot of people set up hawk signals and stuff like this for this operation. I mean, you could treat it like a hawk where it's dark, or you could treat it like just regular old mid-block crossing. I personally am not a massive fan of hawks. I like signal heads to be on all the time. I don't know about you guys, you know. And yeah, the existing. Oh, why did I say that? Oh yeah, in our old configuration, it was difficult to do this. Pedestrian safety. So this is what Eric and I were talking about during the break. So for years, the accessible pedestrian systems have been saying, well, we have an extended press feature. When you walk up and you push the extended press, the button does something different. It talks louder, it buzzes, it does this, it does that. Okay. Now, previously in NTCIP version 2, the old controller data structures, it doesn't matter how long you push that button, the controller's not doing anything different. It's going to load the same walk and don't walk timers. Now, and Ayrton, you told me it's 2 seconds is the MUTCD's recommendation. Now we can tell Omni, hey, if somebody pushes the button for 2 seconds, load a different timer. You know, what was Olivia's old term? Visually and audibly impaired individuals. Uh, uh, Now, it might take them a little bit longer to cross the road because they're visually and audibly impaired. So they walk up. They've been trained to push the talking button for 2 seconds. It loads a different PED time. Instead of 20 seconds for clearance, maybe 30 seconds if it's a big road or something along those lines. We're finally able to leverage the features that APS have been saying that we've had for years. So progression, when you're out there programming, hopefully by this time next year, and the timing sheet says alt walk 2 or something like that, you're going to know what the hell that means. heck, what the heck that means. It's almost time for lunch. Presence detection. Now, for overhead detection systems, your grid smarts, BioVisions, no traffics, Iteris, all the things, right? They've been saying for years that we have crosswalk detection and everything. Well, what's it going to do to the controller? Hey, you got a call. Well, yeah, thanks, but there's already somebody in the zone. So now we have an attribute for the PED detectors called presence detection that we can then get that data from the overhead detection technology, whatever it is, and then the traffic controller can react differently to a presence detector versus an actual push button detection. And then my favorite, non-lock. Again, kind of the same idea with the overhead PED detection. I've been accused of being a pigeon when I'm on the phone, so I just pace randomly. And I see the same kind of behavior of people at traffic signals, especially in like Pigeon Forge. They're tourists. They have no idea where they're in Gatlinburg too. They have no idea where they're going. They're just, oh wow, it looks so much. And then as detection companies continue to improve their overhead detection solutions to detect pedestrians and place PED calls, there's one gaping hole in the way we used to do it. When you push that button, it locks the call, right? And of course, you guys go out and fix the buttons because they've been smashed and the call is always on. So what if there's overhead detection and somebody's pigeoning the intersection, the corner of the intersection, and they go from one tactile dome mat to the other? They're just placing calls. If they lock, then that intersection is basically going to be a PED recall as if they smashed the button. That's why we created the non-lock attribute. So when they're pigeoning the intersection, they walk in, oh, McDonald's is over here, and they walk away from the zone, call goes away. So this is an essential for deploying any overhead detection. You know, even when I was here, the overhead detection peeps were like, oh, we can do PED detection now. I'm like, yeah, you're not solving for pigeons though, you know, but now they can. You know, we have megapixel grade cameras, we have radar sensor, radar camera fusion, all the things, right? And now we can solve for pigeons and use the overhead stuff as they want us to use it. And last one, red light PED protect. All right. This is my favorite one. Doing this in one place, Joseph's going to let me do it here. This is combining red light protect and PED operation using a logic gate. Red light protect is configured for all phases. However, at the minimum, doubling red clear. So we have two sets of gates. One gate that latches the PED movement, or latches the PED push button and creates a logic latch that's going to hold for red light protect. It's like a second level PED detector that red light protect will need to trigger. And then the other gate is a trigger point when the active phase goes into yellow, or at the end of yellow or start of red clearance, and that latch is made, the PED push button. Then that second gate activates a vehicle detector that triggers red light protect for the active phase, forcing the red light protect actuation, or the red light protect activation. I'm using this at that intersection in South Portland, Maine, because there's a lot of pedestrian crashes, a lot of pedestrian fatalities there, because people just kind of run the red light all the time. I want to use this at school zones. Here in Sevierville, Joseph and I worked this up years ago. School zones go to free in the morning to use Max 3, Dynamic Max 3. Geez, how old am I? We use Dynamic Max for loading and unloading. So the central system is already putting the intersections in free. So it's just a little bit more configuration to use this feature to go to free, and then during free, it's loading the red light protect plans. Those logic gates become relevant, and then any pedestrian service during school zone loading and unloading, kids walking to school. Or let me go back one. There's a reason. There's a reason for this madness. Anytime with kids walking to school, they push that button, they get 4 more seconds before, well, there's 4 seconds before they get their walk. Okay, kind of sounds like advanced walk, except it's not advanced walk. It's not leading pedestrian in interval, because the intersection, as Wayne pointed out, is completely locked down. What are we solving for? The guy who's not paying attention and runs the red light, and then not paying attention to the point where there's a kid in the sidewalk. This is why I want to do this. I was in Poway, California 2 weeks ago, and I presented this to them, and they're like, "Yeah, give us a demo. Show us this working with your cyber cabinet, and then we'll talk." And then, but as I was talking to the city engineer, she was like looking at me kind of funny, like, "What's the catch? Where are you going to tell me this costs $1 million?" And then I said, "You're wondering how much this is going to cost you?" She said, "Yeah." I said, "You own it already. This is in Transparity, your central system. This is inside of Omni. You have push buttons. You own the system already. Just let us be wicked smart." And a little New England shout out. And we'll show you how to do this. It doesn't cost any money. However, Halloween, San Marcos, California, 3.6 miles from our office. Kids crossing this crosswalk right here. This is a very strange intersection. The geometry of the roadway, it is an uphill. If you're driving to the office from San Marcos, up San Marcos Boulevard, it is an uphill left to go from here to here. Our office is up here. Somebody turns left to go onto Rancho Santa Fe Road. Kids in the crosswalk. You guys can, I don't have to paint the picture anymore. They're there. 3.6 miles from the office. There's a couple hundred people who work in our office, so somebody's kid goes to that school. I went to school here. I go to school. I went to school in Maine too. We can do this everywhere. Why aren't we doing this everywhere? Okay. Soapbox. Okay. And again, bottom line, you guys can't see this here local. This doesn't cost anything. Logic gates, red light protect, and Omni 3.4. And if you don't have Omni 3.4 or 3.9, we don't charge for upgrades. So we can do this. All right. That being said, looks like there's maybe a few more chats. Ayrton, you want to open this up while we still have a minute?
Yeah, no, the ones that you have there are already covered. So I don't have any other questions. Now is the time if you have a question to put in the chat box.
Surprised that nobody's asked if this is Jameson.
I'm gonna go ahead and ask a question or just have a comment. One of the things that I always hear about the red light protect, the extension of the red light, is that locals learn about it.
Yeah.
And they start pushing it.
Yeah.
So what would you say to counteract that when an agency is saying, "Well, I'm not going to install it because after 1 month the locals are going to learn it and keep pushing it"?
I say we taught them how to look at the PED signal heads with CNA. And, you know, I used to drive State Route 66 home every day, and I know, and I could tell when the light was about to change because the Main Street PEDs, which were non-actuated for years, would start counting down. I'm like, oh, I need to speed up. So it's already a thing.
Yeah.
I mean,
one thing, like I mentioned to you before, on the leading pedestrian intervals, what I have noticed in some places in Knoxville is that folks are learning that whenever the walk is up, they actually can go because the lights are all red. So unfortunately, we are the problem. The drivers are the problem. We create problems, we create solutions for this, but then we go ahead and keep pushing and keep making bad things. So.
I'm gonna build on that, and I'm gonna quote Don Moss from Intersects 2016. He sat on the panel with Craig Gardner from Q Free and the dude from Rhythm, and you said the bold thing and saying until the cars are intelligent and they can drive themselves, and we won't have any effective metering. Adaptive is going to have its limitations because there's always the human element. I murdered your quote there, but that's about the same point. as long as we're in the driver's seat, we're going to screw up. We're going to win and we're going to lose. But damn it, we may as well try.
All right, so I don't see any other questions here coming in or comments. Thank you, everybody that participated. I think we had 135 top on the session. I'll make this available for you guys as soon as I download it, the session. One thing I need to say from the University of Tennessee Center for Transportation Research, of course, we're not endorsing any of the companies here that were presented. What we do is bring you the latest and greatest that we have access to, and we like to share that with you. So if you have any questions, comments, you already have my email. Again, you should have the presentation. You have Eric's, you have Don Moss, everybody else's email here that you can contact. And one last thing, we're going to have MMU training in person coming up here in Tennessee from folks at EDI.
Oh, cool.
So they're gonna come down. So that's gonna be in April. I'll give you more information, and you have information on that on our calendar. All right. So thank you again, Eric. Thank you, Don. Thank you, the City of Sevierville, and I'll see you guys next time.
All right. See you, Zoomers. Thanks.